안녕하십니까? 오늘 글로벌 PM 서밋 2026의 사회를 맡은 일리노이 공과대학의 전가연입니다. 바쁘신 가운데 Good afternoon, ladies and gentlemen. My name is Ka-hyun Jeon from Illinois Institute of Technology. It is my honor to serve as a moderator for today's summit. 바쁘신 가운데 한미글로벌 창립 30주년을 기념해 마련된 이 자리에 함께해 주신 내외 귀빈 여러분께 진심으로 감사드립니다. 오늘 서밋의 주제는 AI 시대 글로벌 PM의 미래를 다시 쓰다입니다. 오늘 이 자리는 글로벌 PM 산업을 대표하는 기업의 전략과 세계적 연구기관의 최신 AI 연구, 그리고 국내 산업계와 학계의 통찰을 한자리에서 나누는 뜻깊은 시간입니다. 특별강연 이후에는 AI 시대 PM의 성장 전략을 주제로 심도 있는 패널 토론이 이어집니다. 건설 AI와 PM 분야의 국내외 최고 전문가들을 모시고 현장의 생생한 목소리가 오가는 시간이 될 예정이니 마지막 순서까지 많은 관심과 참여 부탁드립니다. 그럼 먼저 오늘 행사의 문을 열어주실 개회사가 있겠습니다. 개회사는 건설산업 비전 포럼 공동대표이신 강호인 전 국토교통부 장관님께서 전해주시겠습니다. To open today's summit, please join me in welcoming our opening remark speaker, Mr. Ho-in Gang, from Minister of Land, Infrastructure of Transport, and co-chair of the Construction Industry Vision Forum. 강호인 장관님을 큰 박수로 맞이해 주시기 바랍니다.
존경하는 내외 귀빈 여러분, 안녕하십니까? 전 세계 건설 산업의 미래를 논의하고 새로운 이정표를 세우는 글로벌 PM 서밋 2026의 개막을 선언하게 되어서 매우 기쁘고 영광스럽게 생각합니다. 그리고 오늘 서밋에 참석해 주신 세계 석학과 전문가 그리고 참석자 여러분을 진심으로 환영합니다. 우리는 지금 인공지능과 디지털 트윈이 산업의 지형을 근본적으로 바꾸는 거대한 전환의 시대를 살아가고 있습니다. 오랜 시간 인간의 경험과 노동에만 의존해온 건설과 PM 영역 역시 물리적 현장과 가상세계가 실시간으로 소통하는 패러다임의 대전환을 맞이하고 있습니다. 이러한 중차대한 시점에 세계 최고의 석학과 전문가 세 분을 연사로 모시게 되어서 매우 뜻깊게 생각합니다. 이스라엘 테크니온 공과대학 라파엘 섹스 교수님은 현장 상태와 설계를 실시간 양방향으로 비교 관리하는 디지털 트윈 건설 프레임워크를 정립하셨습니다. 이는 AI 기반의 고속화 세계를 통해 공기 단축과 자재 낭비 감소라는 생산성 혁신을 이끌어내었으며 글로벌 PM 기업이 플랫폼 자율 경영으로 진화해야 함을 역설하고 있습니다. 한편 뮌헨 공과대학의 안드레아 보어만 교수님은 자연어 대화만으로도 3D 모델을 즉각 창조하는 최신의 텍스트 투 BIM 프레임워크를 정립하셨습니다. 아울러 비전 기술과 그래픽 신경망을 결합하여 타설공 정보의 병목 현상을 실시간으로 추적 제어하는 프로세스 중심의 디지털 트윈의 초석을 완성하셨습니다. 그리고 영국 터너앤타운젠드의 COO로 계시는 데이비드 Whysal께서는 세계적인 PM 기업의 실제 AI 도입 사례와 생생한 실무 인사이트를 우리와 함께 공유해 주실 예정입니다. 바쁘신 일정에도 불구하고 오늘 발표를 위해 멀리 독일, 영국, 이스라엘에서 직접 참석해 주신 세 분 발표자에게 특별히 감사드립니다. 또한 토론회에서 고견을 들려주실 이강 교수님을 비롯한 토론자 여러분께도 진심으로 감사드립니다. 존경하는 참석자 여러분, AI 시대의 건설과 PM은 기존 프로세스의 미시적 개선을 넘어서서 현장의 데이터와 직관적 언어를 지능화된 지식 인프라로 전환해야 합니다. 이를 통해 포트폴리오 전체의 생산성과 효율성을 극대화하여 새로운 가치를 창출해야 합니다. 오늘 이 자리에서 공유할 세계적 석학들의 지혜가 우리 건설 산업의 한계를 극복하고 글로벌 경쟁력을 확보하는 강력한 무기가 될 것이라고 확신하며 오늘 서밋이 여러분 모두에게 창조적인 영감을 주는 귀한 시간이 되기를 권합니다. 마지막으로 오늘 귀중한 행사를 마련해 주신 한미글로벌 김종훈 회장님께도 이 자리를 빌어 깊은 감사드립니다. 감사합니다.
뜻깊은 개회사를 들려주신 강호인 전 장관님께 다시 한번 큰 박수 부탁드립니다. 이어서 한미글로벌 김종훈 회장님의 환영사가 있겠습니다. 김종훈 회장님은 국내 최초로 PM을 도입하여 대한민국 건설 산업의 글로벌화와 선진화를 주도해 오셨습니다. 환영사를 해주실 김종훈 회장님을 큰 박수로 맞이해 주시기 바랍니다. Next, please welcome Chairman Jong-hoon Kim of 한미글로벌 for his welcoming remark. Chairman Kim pioneered the project management in Korea and has led the globalization and the advancement of our construction industry.
존경하는 국내 기빈 여러분, 그리고 이 자리에 함께해 주신 건설산업 관계자 여러분, 안녕하십니까? 한미글로벌 회장 김종훈입니다. 오늘 AI 시대 글로벌 PM의 미래를 다시 쓰다라는 슬로건 아래 열리는 글로벌 PM 서미트 2026년에 참석해 주신 모든 분께 진심으로 감사를 드립니다. 우리는 오늘 AI 기술이 몰고 올 거대한 변혁의 소용돌이 속에서 글로벌 PM의 새로운 이정표를 세우고 건설 산업이 나아갈 내일의 방향을 도모하고자 이 자리에 모였습니다. 주지하시다시피 건설 산업은 오랫동안 인류의 삶과 문명을 만들어 온 산업입니다. 도시를 건설하고 인프라를 구축하며 사람들의 삶을 연결해 왔습니다. 그러나 지금 우리는 과거 어느 때보다도 큰 변화의 시기를 맞이하고 있습니다. 인공지능과 디지털 기술은 건설 산업의 업무 방식뿐 아니라 프로젝트를 계획하고 실행하며 관리하는 방식까지 빠르게 변화시키고 있습니다. 그러나 기술이 아무리 정교하게 진화할지라도 프로젝트를 성공으로 이끄는 핵심은 결국 인간의 통찰과 판단, 그리고 유기적인 협력에 있습니다. 각 분야의 전문가들이 지식을 공유하고 연대할 때 비로소 기술은 인류를 위한 위대한 가치를 만들어낼 수 있습니다. 오늘 이 서밋이 국가와 학계, 산업계의 경계를 허물고 미래를 위한 지혜를 모으는 협력의 장이 되기를 기대합니다. 특히 오늘 이 자리를 빛내주시기 위해 귀한 걸음을 해주신 기조연설자 데이비드 Whysall 터너앤타운젠드 경영총괄 사장님, 안드레 보만 뮌헨공대학교 교수님, 그리고 라파엘 삭스 테크니온 공과대학교 교수님께 깊은 감사의 말씀을 드립니다. 특별히 제가 터너타운젠드라는 회사를 조금만 더 소개를 하게 되면, 아침에 제가 데이비드하고 조찬을 하면서 물어봤는데 지금 미국에만 8,000명의 직원을 고용하고 있답니다. 영국 회사가 미국에 들어가서 불과 몇 년 만에 8,000명의 인원을 고용하고 있는 회사고, 글로벌하게는 25,000명의 직원을 갖고 있는 아주 세계적인 회사입니다. 참고를 하시고, 오늘 발표를 하신 데이비드 경영총괄 사장님은 전 세계를 전부 다 관할하고 있는 분입니다. 아울러 오늘 행사를 주최해 주신 건설산업 비전 포럼 강호인 공동대표님과 사회를 맡아주신 정가현 교수님, 그리고 풍성한 토론을 이끌어 주신 이강 교수님과 토론자 여러분께 깊은 감사의 말씀을 드립니다. 또한 바쁘신 가운데 함께해 주신 학계와 산업계 전문가 여러분들과 후원해 주신 과학기술정보통신부 및 국토교통부 관계자 여러분들에게도 고개 숙여 감사드립니다. 올해는 한미글로벌이 창립 30주년을 맞이하는 뜻깊은 해입니다. 그러나 오늘 이 자리의 의미는 한 기업의 기념 행사에 있지 않습니다. 우리가 함께 고민해야 할 건설 산업의 미래와 글로벌 PM의 새로운 역할 정립에 의미가 있다고 생각합니다. 오늘 세 분의 세계적인 석학들이 제시할 AI 시대의 PM 성장과 전략, 건설 환경의 AI 진화에 대한 논의들이 우리 산업의 국제적 협력을 확대하고 실질적인 혁신을 촉발하는 마중물이 되기를 바랍니다. 다시 한번 귀한 시간 내어 참석해 주신 모든 분께 감사드리며 오늘 이 자리가 여러분 모두에게 새로운 영광과 도약의 기회가 되기를 진심으로 기원합니다. 감사합니다.
먼저 기조강연은 터너앤타운젠드의 경영 총괄을 맡고 계신 데이비드 와이셀님께서 터너앤타운젠드의 성장 전략과 AI 시대 PM의 미래를 주제로 말씀해 주시겠습니다. 먼저 앞으로 모시겠습니다. 데이비드 와이셀님은 건설 사업비 관리의 선도 기업인 터너앤타운젠드에서 글로벌 운영과 성장 전략, 리스크 관리를 총괄하고 계십니다.
Firstly, could I say it's a real pleasure to be here today. I would like to thank Hamley Global, in particular Chairman Kim, for his very kind invitation. Our relationship with Hamley Global is very special to TownTownsend. It goes back over 17 years. In fact, our relationship goes back over 30 years. I'd like to wish Hamley a very happy 30th anniversary and look forward to our continuing partnership as we move forward together in Korea, but also globally. It's my first time in Korea, and I was about to say also what a beautiful, vibrant city it is. It's a very special city you have, and I've been so welcomed over the past few days. I'd like to say thank you. So Chairman Kim has asked me to explain a little bit firstly about TownTownsend and our business. He often comes to London to see us, and he asked me the question about how we managed to grow so fast. So hopefully I'll share, Chairman Kim, some thoughts on that with you and the rest of the room. I'll then talk more about project management in the AI era. The experts will follow me, but I'll share some insight on what we're doing around AI and technology. It's something we've placed absolutely at the heart of our strategy going forward as a business. A short introduction to myself. Yes, I'm the COO of TownTownsend since March this year. I've been with TownTownsend for 22 years, since I started as a graduate in London. And as TownTownsend, we put a lot of focus on to bringing graduates into our global business and also helping them fulfill their career and accelerate them into management positions. So Brian, who's here today, who runs our Asia Pacific region as managing director, was also a graduate, as was Thomas, who runs our career team here in Seoul, as was Nick, who's the managing director for our Northeast Asia business. So we are 4 graduates who have come through TownTownsend in the past 3 years. As well as being COO, I look after our global energy business. It was great to have a meeting this morning with KEPCO about how we can support them alongside Hamley Global globally. I've been involved in lots of mega projects around the world, particularly in the UK, such as Heathrow Terminal 5 and Terminal 2 and Crossrail, a new metro through London. I also share a passion, as Chairman Kim does as well, for improving our industry. I was fortunate to chair Construction Excellence in the UK for 6 years. As part of that, really tried to bring a culture of collaboration across the industry to help it improve. But I think we've got a long way to go still. I was involved in a number of industry initiatives, and I'm very proud to be a chartered surveyor, a member of the Royal institution of chartered surveyors. As I mentioned, we've known Hamley Global for many years, for 30 years, and our JV has been in existence for over 17 years. It's a partnership built on trust and respect for each other. We are working together successfully here in Korea, but now also globally. It's perhaps Townsend's most successful partnership anywhere in the world, and one we're very, very proud of. It brings together leading project and construction management business in Korea with our global management, program management and cost management specialisms as well, allowing us to support iconic projects here in Korea, but now also important sectors that are so critical to our future, such as data centers and nuclear energy. I really believe together with Hamley Global, we can support any clients here in Korea, perhaps also more importantly as well as we go forward, any Korean client around the world who want to deliver major projects. I'm now going to show you a short video, which I hope gives you a good understanding of the kind of business that Turner & Townsend is. So I hope that video gives you a feel for Turner & Townsend. We're an organisation that has a strong sense of purpose. As Chairman Kim talked about in his opening address, society needs the global construction sector to get better. It's got to get better to deliver some of the huge things we need in society for the future. We believe in a resilient and sustainable future, an environment that creates opportunities for all, strong economic growth. But our industry's got to deliver the major projects and the global portfolios that allows these big societal needs to be realised. We've got a passion as an organisation to transform our industry, and we share that passion with Hamley Global. We want to set new standards in how major projects and global portfolios are managed and delivered, and certainly that's something that drives myself and Turner & Townsend's global leadership team and the 24,000 people that work in our business. For those less familiar in the room, Turner & Townsend, you can see on the slide, we're a global program management business that operates around the world with a turnover of $7.5 billion US dollars, with now almost actually 25,000 people in our team, work across 250 offices in 64 countries, and overseeing $3 trillion of capital spend every year. We bring deep sector strength and insight, operating across 3 segments or super sectors. From real estate, supporting corporate occupier clients manage their portfolios, supporting data centres as they continue to be built around the world, healthcare, life sciences, retail, sports, iconic buildings. Infrastructure, supporting the growth in aviation, defence and security, ports, road and rail transit, highways, water, and energy and natural resources, where I spend a lot of my own time supporting clients develop the energy needs of the future across nuclear, offshore wind, onshore wind, transmission, conventional energy, mining, and conventional sources of energy as well. I'll talk about Korea. Across Asia, we have a team under Brian's leadership of over 5,500 people with hubs in areas including Japan, Singapore, Kuala Lumpur, India, Hong Kong, and Indonesia. Asia is a very important market for Townsend. It's the centre of innovation and global growth. We want to be here to play our part in that, and Korea is actually really at the heart of our strategy and the heart of Asia. It excites us of what we could do here, working with Hamley Global and local team. In Korea, combine our global delivery experience, the local knowledge of Hamley Global, the leading South Korean construction management firm. We share a passion for innovation together. Hamley Global, one of the first organisations to bring together project and construction management methodologies. They've consistently led the industry in integrating project management processes with cutting-edge innovation and technology. And this collaboration enables us together to deliver premium cost management and project and construction management services in Korea, but as I said earlier, also support Korean companies as they export those capabilities and deliver projects anywhere around the world. You can see where our teams are around the world. These numbers on the global chart are already out of date because we're growing all the time. So as Chairman Kim said, we're near 8,000 people now in America. You can see how we're growing, and we continue to grow, and we've set our strategy for growth for the next 5-year cycle. We're seeing very strong growth already this year across Asia, the UK, Europe, and the Americas. And we tend to double the size of the business every 5 years. I've said over breakfast this morning, Chairman Kim asked me again, how do we grow so quickly? I think there's 3 things that we get right. One, we put a lot of time into developing talent. We are passionate about the development of people. It's the most important part of our business. Secondly, we build long-term relationships with our clients. A lot of our clients go back over 25, 30, or even 35 years. We invest with them. We innovate together. We partner together. We act as a partner and extension of them. And thirdly, we like to collaborate. We can't do things on our own. We collaborate across the supply chain with organisations that share our values to transform an industry, to move forward and make a difference. Very, very important. So focus on talented people, be passionate about clients and delivery and supporting them, and making sure we collaborate with organisations that share our values. Before I go on and talk a little bit about our growth strategy going forwards, just to bring to life some of the projects that we're involved in. We look at projects in 3 areas. Major projects, standalone big mega projects, big global portfolios, and also projects across our core geographic markets. Just some examples. Here in Asia, we're delighted to support Legoland Resorts and Merlin Entertainments, deliver here in Korea, helping them deliver the project in a way that delivered cost savings around 20% on what they could have done without us. In the UK, Lower Thames Crossing is a huge mega project, $15 billion, and there we've built a technology platform to run the project, using AI to manage costs. And the Celtic Interconnector, bringing offshore wind off island, an interconnector and subsea cables that brings clean energy to mainland Europe, a first-of-a-kind technology that we'll be working with and exploring around the world. Some of our global portfolios, we support Nissan. We're very proud of our relationship that goes well over 30 years with Nissan. We've supported well over 2,000 projects globally, helping each project get better every time from learning. In the video, you may have seen Heathrow. As well as big capital projects, they also have a portfolio that we manage on their behalf, delivering hundreds of projects every 5 years to support the airport operate and run and become more resilient for the future. And TenneT, who run the grid across large parts of Europe, we're supporting across many projects including their new 2 gigawatt project, which involves fabrication in Singapore and Malaysia through to installation of the fabrication units in the North Sea and in Germany. In some of our core markets, we've been very proud to work with JYP Entertainment, building their headquarters here in Korea, working with a flagship architect to do that. In places like New York, working on their airport, New York Liberty, and Hinkley Point C, a new nuclear reactor in the UK, where we'll be supporting 6 million homes have clean energy for over 60 years. And now the UK is looking at how, and using Townsend to look at how they can learn from their first project and drive the benefits of replication into the next nuclear project called Whysall C and drive 20% improvement on cost and time. So that's probably a little bit enough about where we are and what we are as a business. Chairman Kim asked me to share our thoughts or share with you some of our focus on our growth strategy. So I'm now going to look forward and share with some themes that we've developed that have really driven our strategy that we've set earlier this year for the next 5 years of growth. And this was an 18-month process involving lots of people around the business globally collaborating to set a strategy for the future. Firstly, demand. Demand for mega projects is only increasing. We've seen the amount of $1 billion plus projects double over the last 5 years alone around the world. We're seeing pressure put on industry to deliver. Clients struggling to set up projects effectively. Supply chains struggling to respond to the demand required. Data center spend alone has gone from $300 billion a year to $700 billion a year in 2 years. It's likely to get towards $3 trillion of spend per annum by 2030. Transmission, as everybody rebuilds the grid, will go from $400 million a year to $1.5 trillion a year of spend. In defence and nuclear energy, we're seeing investment double. Only a small number of organisations have the capability globally to manage these major or mega projects around the world. The industry needs to work together to build the capability and the capacity to be able to manage them. We're seeing competition change. We're seeing strain on talent, and organisations compete for talent around the world. Lots of organisations moving towards programme management, leaving behind perhaps elements of engineering. We're seeing technology companies bring new ideas to programme management, how it can be done. Our focus is very simple, to stick to what we're good at, helping clients set up and manage major projects around the world. But of course, keep collaborating. Technology we'll talk more about will transform our industry. It has to be embraced. Organisations that do not embrace technology probably won't be here in the future, no matter how big you are or where you may be working today. We are placing technology absolutely at the heart of our growth strategy. And transition, the world's in a state of transition. We're seeing how it fundamentally operates a new normal. We're seeing a new energy system built around the world. We're seeing technology companies change how the world operates. We're seeing space become accessible. We're seeing countries look at defence systems and the way they operate and national security. The world is shifting, and we're making sure we're aligning our focus and our growth strategy to the big tailwind sectors of the future. But, as I've already touched on, at Townsend we generally believe the industry has some fundamental problems. We have to help fix and improve performance for the future. We see a broken industry that needs to get better globally. Whilst I recognise some of the improvements made in the market in Korea, globally the industry trends are not good. Productivity is generally poor and hasn't moved a great deal in decades. The supply chain remains underinvested, very fragmented, and innovation fails to come up to clients and to utilise. There's too much of a focus on passing and transferring risk into a fragile supply chain. Technology in our industry has failed to be adopted at the rate required for the future, and we're looking into a skills crisis with an ageing workforce in many countries, and we're seeing the erosion of technical skills. As major projects increase, we see clients really struggling with three things. One, how do they build the capability to manage mega projects? Secondly, how can they attract and manage a supply chain for the future that's reliant, that's robust, that's resilient? And thirdly, how can they execute big projects in a confident manner? And this is where Turner & Townsend's focus is. So our response, our growth strategy, what our focus is. Our vision is very simple, to be a global leader in what we do, a global leader in major projects and portfolios, a leading program management business, but a partner that works with our customers to redefine and set new standards in our industry. Secondly, those standards need to become driven into the projects we work across. We have to take leadership and responsibility for being a beacon of what good looks like. Thirdly, we want to keep collaborating and partnering across industry, helping industry learn and get better over time. We're not an engineer. We're not a designer. We're not a technology consultant or technology organization. We're not a constructor or contractor. But we'll only get the answers we need if we collaborate with those organizations and those markets for the benefit of our industry. Four, we're going to remain very balanced. We're committed to have a business that's balanced across our three segments, ensuring we can build a resilient business for the long term. We've got to deliver solutions for our clients, take accountability for outcomes and supporting them as they deliver their projects, rather than just focusing on professional advice and services. And finally, we have to align people with data, knowledge, and technology. Technology companies cannot deliver major projects and portfolios. Project managers have to stay relevant and competitive in a new world, and they'll have to embrace technology. But technology needs data and knowledge to be effective. We have to make sure we align these things, people, data and knowledge, and technology together as we move forwards. To put our growth strategy into action, we are focusing on a number of investment areas, making sure we continue to invest in our people, exceptional people, raising standards in our technical training academies around the world, global leadership programs to make sure our leaders can think and develop the leaders of the future, making sure our leaders understand AI, they can utilize it, embrace it, turning technical people into solution thinkers and program managers of the future, capable of unlocking performance. Secondly, we're investing like we've never done before in technology, collaborating with technology partners on a global basis and also niche organizations around the world. Thirdly, we're investing in the deep sector expertise required for the future, those resilient markets required to deliver society's needs. Fourth, we're trying to build the world's leading data and knowledge asset. It's so critical for the future to embrace AI and technology. We've got to make sure we have a strong data and knowledge asset for the future to enable AI to be successful. And we're building depth and breadth to our service offer, more construction management capability to support our clients deliver projects that unlock real value. And my job day to day is making sure we connect our business globally. 24,000 brains connected every day. Our clients may access one person connected to 23,999 other people sharing learning over 80 years. And we continue to evolve our service model, looking at performance-driven program management solutions. So focusing on our markets of major projects, global portfolios and core markets, building solutions to help clients set up and advise them on how to structure projects, how to commercially create supply chains to drive performance, and how to deliver well. Putting depth to our service model and making sure technology sits at the heart of each of our service lines, and continue to collaborate with partners on how they invest and develop and operate facilities. So now project management in an AI era. I'll touch on share some of the things we're doing around AI across our global business. But look, our industry has to quickly embrace AI. The last 6 months alone has seen huge shifts in AI investment and opportunities for industry moving forward. As I've said already, organizations have to embrace AI if they want to be here in 5 years' time. AI will make us a far more productive industry. It allows us to attract a new generation of talent into it. But also, ultimately, it will help us deliver value, more value for our customers, not just productivity. I look at AI as a work in progress. Today, we all treat it with respect. It's perhaps 20 to 60% accurate in some of the things it provides. It needs human beings to look at it. It needs to have oversight, but it will improve. If you looked at AI as a person, it might be an intern today. But in a few years' time, it'll be as capable of some of the experience that sits in this room. So in the last 6 months, we've seen lots of changes in AI capability and uptake. The technology landscape is rapidly changing and pace accelerating. AI is going to have a material impact across the working world and across our industry. The big change we've seen in the last 6 months or 12 months has been the development of agents. These are not simple chatbots. These are autonomous workers that can interact with tools, systems, they want to learn, and they have perception and reasoning. We have to have a growth strategy. You have to have a growth strategy that brings those technology advancements into your businesses going forward. The race is on to understand opportunities for automation, to think differently, but also make sure you can find fact from fiction in what is a very busy AI market to understand the truths actually out there and how you can unlock value. What is the industry saying about AI? Well, 90% of professionals surveyed from the Project Management Institute are saying that it'll have a moderate impact on project management. I don't disagree. I'm in the 50% who say it's going to have a major transformative impact going forward. Less than a quarter of project managers currently use AI tools every day. This presents a significant readiness gap. The PMI predicts that AI agents will automate risk alerts, schedule optimization, and reporting. I think it can do a lot more. Our own research shows that 87% of industry leaders agree AI will significantly enhance our industry. However, almost half of our industry leaders have done almost nothing to date. Only 12% are effectively utilizing it. 55% of construction leaders predict automation will significantly disrupt our industry within 5 years. As a minimum, AI today is able to provide research, realize productivity tasks you ask of it. But as AI continues to mature, it'll be able to undertake tasks linked to productivity or product delivery. It will be able to compile reports, analyze schedules, manage change on our behalf. The transformation will be as agentic AI becomes widely accessible. Agents will learn autonomously and be able to manage elements of projects without being prompted. If we look at the typical project lifecycle, I know there'll be some case studies later, we can already see AI use cases happening today. Business cases at the front end of projects. AI is already using or developing business cases for major projects, using historical data to predict baselines. We're seeing AI utilized in bidding for work. In design, we're seeing the opportunity to utilize AI to produce designs based on previous learning, with humans there simply to assure and check what's being produced. In delivery, we're seeing the ability to automate contract management, to run agentic PMO functions that provide project and portfolio management insight. Also able to monitor sites, to capture progress in real time, to utilize AI to compare as-built drawings, pick up issues, quality issues, and drive performance productivity in the way perhaps we haven't done before. And then, of course, in operation, AI plays a huge opportunity to improve the maintenance and operation of facilities. Our perspective is that AI will unlock productivity and therefore efficiency in the product process, but ultimately it's about creating value for our customers. We'll be able to provide results quicker, we'll see performance we can't see today and improve it. We must target and measure increased value and define what good looks like in terms of performance improvement. If we use AI in estimating, how does it improve accuracy of baselines? We know today 98% of projects over $1 billion are over budget. That can't be right. In controls, how do we get AI to generate schedules in flight linked to productivity on site with performance and forecasting? How do we help it reduce rework and improve schedules? How do we ensure we improve health and safety, alerting us when biometric data is telling us workers are tired before accidents happen? It's got to ultimately tackle the issues around our industry that delivers greater value, not just productivity. So we believe AI represents a once-in-a-generation opportunity to transform our industry. I'm now going to share some insights to what we're doing as Townsend to embrace AI and make some investments for the future. Firstly, here's a set of guiding principles that I'm using and our exec are using to make sure we realise the opportunities and value from AI. Firstly, we're prioritising investment that materially impacts our customers, that creates more value for them. It's got to produce better products, faster, safer delivery, and better quality outputs. Secondly, technology, including AI, will only be useful if we have the knowledge and data captured and stored to allow it to be effective. We're putting a huge amount of investment into collating knowledge and data around the world. Thirdly, we're learning to fail, but fail fast. Technology projects have a high failure rate. We're not used to that in project management. It's not easy for us to accept failure in project management. But as the technology changes, technology projects will fail. We have to learn, move on, and fail fast. Certain investments, innovations, learn from and reinvest back for the future. Fourth, we've got to measure and have a really clear commercial strategy. Measure the return on investment we're making across the technology investments we're making. Fifth, we've got to co-create with clients and partners. We're very fortunate that we have over 500 technology professionals in Townsend. But as I've said already, we're a program management business. We have to collaborate with technology companies around the world, and in some cases investing billions that we can learn from. Technology with project and program management professionals with knowledge and data with the thing that unlocks AI into the future. And finally, we'll align our strategy with our people strategy. People and technology are two sides of one coin. You can't do one without the other. We have to align the two. I strongly advise that your leadership start with your leadership. Get them comfortable with AI. We see across the industry that too many senior members of the industry fear change. They have to embrace it. They have to become AI advocates and sponsor it if it's going to be successful. So we're putting significant focus and investment in AI. We're transforming our service model. I'll show some examples in a second, enabling productivity to be realized across our service model. We're realizing productivity for our staff. We're about to launch an AI productivity tool called the Hive Mind, allowing 24,000 people every day to access insight and learning from over 80 years of history. We're building technology platforms that can house major projects and portfolios, that allows us to run projects and portfolios from our platforms, collaborating with technology companies to hang AI products and processes off them. The platforms allow us to go deeper into the supply chain, to understand risk and opportunity, to improve performance. We're empowering our people, helping them understand AI, putting in place the policies for effective AI use, recognizing the risks that also exist with AI, and make sure people understand those. We're harnessing knowledge and data, I've already talked about, aiming to build the largest data set across our industry. We're transforming our central functions, making sure they're highly effective and productive for the future. We already have agents working across our marketing teams, our finance teams, and our HR function. At present, AI is also a lot about perception into the market. We're making sure that we work across our market to bring facts to a lot of AI noise and make sure people are clear on the opportunities, what it can and cannot do. And finally, embedding governance, making sure that AI is adopted successfully, effectively, but in a way doesn't expose risk to our business or to our customers. I mentioned transforming our service model. We've analysed our services, over 250 technical disciplines that fit under a service model, looking at how we drive automation into every step. We've prioritised investment in areas of our service model that we think will give the ability for our professionals to do things quicker, faster, to support our clients. So having a really clear view of where those opportunities are for automation is so important and allows us to direct our investments. We've launched our global product lab. One thing that's going to be very critical ahead is that innovation will happen more and more, but it has to be captured and industrialised. We've set up a product lab to capture leading practice from across our business, align technology investment, and create a mechanism to distribute that effectively. AI will not happen without a dedicated focus, somewhere to convene innovation, technology together, and push it across the business. Again, it means 24,000 people can realise the benefits of a single idea somewhere in the world and quickly distribute it. I mentioned we're building technology platforms. Here's an example of our Hive platform. We manage projects from a single interface. This allows us to deliver services, collaborate with other organisations from design, engineering, construction, draw learning and knowledge together quickly, and better help our clients understand project performance in real time. And of course, making it digitally friendly as well, so clients can access project performance anywhere in the world, whether that be on a tablet, a phone, and log in to see how their projects and portfolios may be performing. And I mentioned the Hive Mind. You'll see a little video starting here where someone is asking the Hive Mind for information. They're about to see a client. It's going through our global knowledge base, providing information about that client, where I've worked with them before, the projects, what might be relevant to them. Our Hive Mind platform brings 80 years of learning experience to everyone every day, helping aggregate market insight, compile reports, compile presentations. It's been built with the support of a global technology company and will be launched in the second half of this year. But we're really excited by the power of what it can do. We're realising productivity every day. We've built agents already to help us manage projects. In this case on screen, this agent's helping manage change on a project, analysing the reason for changes without a human being involved. It's generating reports explaining why changes happened, how to deal with the root cause of change, what it means from a contractual perspective, to allow someone to log on, download a report, and talk a client through that without having to compile it. And in this case, we're using AI to help produce estimates, creating baseline estimates for asset types purely by understanding its location and some very basic specifications. We can generate should cost and should take time estimates within seconds, utilising the data and learning we've got from around the world. Of course, as AI becomes more powerful, our learning and knowledge and data becomes more structured, this will get even stronger. So look, thank you again for listening to me. I hope I've been able to share with you a little bit about Tonentownshend and our plans for the future. We're excited by the future and what this industry can do to help deliver the major projects and portfolios for our clients to have such a big impact on society. Thank you again to Chairman Kim for the very kind invitation. It's been a real honour to be here. Thank you for hosting us. It's been a pleasure to be here. And finally, my final message for the room, engage with AI. As leaders, lead from the front and drive adoption across your business, across our industry, and across projects. It's so critical we do it together. Thank you.
네, 이어서 첫 번째 특별 강연이 있겠습니다. 첫 번째 순서로는 독일 뮌헨공과대학교의 안드레 보어만 교수님께서 건설 환경의 AI 빠르게 진화하는 미개척지를 주제로 발표해 주시겠습니다. 보어만 교수님은 뮌헨공대의 게오르그 네메첵 연구소의 소장을 맡고 계시며 디지털 트윈과 건설 자동화 분야를 선도하는 세계적인 연구자이십니다. 2024년에는 건설 디지털 기술 혁신에 기여한 공로로 독일 정보기술 분야 최고 권위의 콘라드 추세 메달을 수상하셨습니다. Please welcome Professor André Borrmann.
Thank you, Kayon, for the very nice introduction. Hello, everyone. Welcome to my presentation. Thanks for the invitation. I'm very happy to be here. Yeah, the title of my presentation is AI for the Built Environment, a rapidly evolving frontier. Before I dive into the details of our research, please allow me to quickly introduce our institute. I'm leading the Tom Georg Nemetschek Institute, which is the institute at the Technical University of Munich for artificial intelligence for the built world. It was founded in November 2020, so 5.5 years ago. It is funded by a very generous donation by Professor Georg Nemetschek. You can see him here in the background on the screen. He is the founder of Nemetschek SE, a quite successful company in the area of AI software. He has donated 50 million euro to TOM, and with this money we can fund the institute. I'm the director of the institute since March last year, and the core of the institute is the interdisciplinary projects. So we have a large number of projects that are run across the university, always between researchers from computer science and researchers from the built environment, architects and civil engineers. The core of the institute is my own group, which is the chair of civil and of computing in civil and building engineering. And this is my group, currently consisting of 25 PhDs and 10 postdocs, all of them working on topics around AI for the built environment. In general, we are focusing on developing intelligent digital tools for the entire life cycle of built facilities, starting at the early phases of design to the very important and detailed engineering of buildings, to the very fascinating but also very challenging phase of construction, the long phase of operation where we focus on things like energy consumption, for example, to finally the demolition of buildings where we think about reusing materials and deassembling buildings. There are a large number of topics under this umbrella. We cannot touch all of them, so I have selected a few of them that I would like to talk about in more detail. These are topics that are related directly to the application of AI in the built environment. First topic I will talk about is generative AI in construction. So how can we create building models? Then I will talk about digital twinning. So how can we create digital replicas of existing buildings? Next topic will be processing of technical drawings, because we know we have still a large number of projects that are relying on technical drawings. I will then come to the construction side and speak about AI-based site productivity analysis, and finally an outlook into the future into AI-based construction robotics. So let's start with the first topic, which is generative AI. So what do we understand by generative AI? We strongly believe in the concept of building information modeling. We strongly believe that digital models really help us to structure all the information that we need for the life cycle of a built facility. However, in the industry, in the practice, many people say that creating these BIM models is very cumbersome and time-consuming. So our question is, can AI help? And we have developed 3 different technologies helping to speed up BIM modeling. The first one is predictive modeling. What is the background here? Well, these BIM tools, BIM authoring tools, they typically have a very complex user interface. As an example, you see Vectorworks here with a large number of different buttons. So you have to undergo a lot of training, and even trained people take a while until they find the right command in these user interfaces. So what we have developed is a predictive system that generates real-time recommendations for the next command. It's a little bit like when you write a text using your smartphone, then actually the smartphone is proposing the next words. And we do similar things, but here for BIM modeling, with the goal to speed up BIM modeling and reduce errors. To do so, we have been using a lot of data, because data is always important for any AI application. We have luckily been provided with a large number of logging data by Vectorworks, which belongs to Nemetschek. We have received more than 90 gigabytes of logging data, so data that shows how individual persons have modeled BIM models across the entire world, essentially. We use this data to train open large language models from scratch. So we did not use pre-trained models, but we trained them from scratch, because the log data is very different from natural language. And you see some of the results here on the lower part. We have trained Llama 2, Mistral, XLNet, and BERT. And the best results we received with Mistral with recall at 10. What does recall at 10 mean? It means that we propose 10 commands, and among them, the right one is there with a chance of 87%, which is quite good given the complexity of the task. To give you a better insight and maybe a practical view on this, I show you the application, how it is used in practice. So on the left-hand side, you see the Vectorworks application, and here a human is modeling a building model. On the right-hand side, this is our application. Here we track what the modeler is doing, and we are proposing the next possible command, like delete the wall again, create a window, create a door in the wall, depending on what the modeler has done before. So this already speeds up the process, because then the modeler does not have to search the next command. He simply can click on the right-hand side. So this was a first step into the direction of speeding up BIM modeling. The second approach was more fundamental. Here we asked ourselves, is it possible to create entire building models from scratch based on human instructions? Here we have developed an agentic approach that we call BIM Copilot or Text to BIM. And it's based on 4 different agentic systems. These agents have dedicated roles. We have one product owner, we have an architect, we have a programmer, and we have a reviewer. They work together and communicate together to create the building model. How does it work? On the top, on the right-hand side, you see the human instruction, something like I want to build a 2-story hotel with 8 rooms on each floor, and so on. This is handed over to the product owner. The product owner is now consulting the architect agent. The architect agent has a lot of knowledge about how buildings are constructed. Like we first have a slab, then the wall, the windows are in the walls, and so on. This information is then used by the product owner to create a very precise specification of the building to be constructed. This specification is then handed over to the programmer in the middle part. The programmer uses the API of a BIM modeling tool, like for example Vectorworks again, and creates programming code, for example in Python, using this programming interface. And doing so, we develop the actual building model in the BIM authoring tool. Then we export this into IFC, which is a neutral standard, and then we can check the model for compliance with certain rules, but also very basic things like, is there any gap between building components? Are slabs really on the walls, and so on? This is done by the reviewer. The reviewer then gives back his feedback to the programmer. So we essentially have a loop here where we consistently improve the quality of the building model. So we go through this loop maybe 8, 9, 10 times. Okay, let's have a look on some practical examples. So here we have the example input prompt on the left-hand side. Create a 3-story L-shaped house with each leg of the L being 8 meters long and 4 meters wide. Place a door at the corner of the L and a window on each side of the L. And you see the results of 3 different large language models on the right-hand side. These studies have been done already 2.5 years ago, so please excuse that these are not the latest large language models here. However, we can also see how differently they have interpreted the task. So the first one, GPT-4o, actually didn't create an L-shaped building, but this was more a Z-shaped building or maybe double L. Mistral Large 2 did a good job. Indeed, this is an L-shaped building, and well, quality is good. Gemini 1.5 failed, actually, so this is not a correct building model. We have to say Gemini 1.5 is an old model. In the meantime, we have Gemini 3, which is much better. So this is actually older results. Second example, I want to build a 2-story hotel with 8 rooms on each floor. The rooms are arranged in groups of 4 on each side, separated by a 4-meter wide corridor in the middle. Each room has a door and a window, and so on. And here again, you see the results from these 3 different large language models using our agentic approach. So in the background, there's always the agentic approach. On the left-hand side, GPT-4o does a good job. Mistral Large 2 also good result. Again, Gemini 1.5, actually, if you look at the interior of the created building model, it's not really correct. So because this was done 2.5 years ago, I asked my PhD student to repeat the investigation around 4 months ago. Now we used newer large language models. We also used more complex tasks, and these are the results. You see, well, the quality is really good. Also, the shape of the buildings is increasingly complex. So we believe this is a very promising technology, and we will see much more of that in the near future. It's really like an evolution path that we can now already feel. Okay, so this was the second approach. The third approach that we have investigated is called BIM operator. Here we use the conventional BIM modeling tools, but we let the agent not use the API, but instead the conventional user interface, the same user interface that the human would also use. We know similar approaches actually from Claude. They call it Claude Computer Use Agent, and OpenAI use it OpenAI Operator. What they do is actually more or less simple tasks like booking flights, shopping, these kind of things are quite common. So we questioned, is it possible to use the same technology now for more complex applications like BIM authoring tools? And yes, it is possible. So what you see here is, again, in the background, the software product Vectorworks, as any human would use it. And on the right-hand side, you see the agentic AI using this tool. And we start with a typical representation of a building, a floor plan that, for example, an architect could have been designed, sketching a floor plan, as you can see it on the left-hand side. So first, the first agent comes and will translate the sketch into a precise specification. We do some image analysis, and then we create a very precise specification, including the coordinates of the walls and the windows. So this is the starting point for the other agent. And what you see now in the background is not a human using the system, but instead it's the agent moving the mouse, doing the clicks, and really operating the BIM tool. And you see it's modeling the walls. It's then adding windows to the walls. It's really creating the BIM model in exactly the same way or similar way as any human would do it. So now we come to the second story. See on the right-hand side the 3D representation. We build the walls for the second story. Again, we put, or not we, but actually the agent puts the windows and the doors into the walls. And finally, we will have a roof on top. So what we have seen here is an agent really creating an entire building model using existing software. And this is, again, quite promising because it means that we do not have to rebuild software, but we can have the agents use the existing software in the same manner that humans could do it. In the background, it looks easy, but in the background, there's actually quite a complex system that I cannot explain in detail here because we don't have that much time. But if you are interested, please contact me, and then we can have a deeper exchange about the actual technology. Okay, the second topic I would like to talk about is AI-based digital twinning. So what is the idea here? Well, actually, in our countries, in South Korea, but also in Germany and many, many other countries, most of the built facilities are already built. So we don't have that big demand for new constructions, but we have to maintain the existing structures. And to this end, we use digital tools again, but we have to create a digital twin of the existing structures. And this is called a digital twin. Yeah, it's including typically the geometry, the materials, but also the condition. All of that is very important, but we in my research group, we focus on first creating the geometry because this is the basis for everything else that comes next. And we use all kinds of capturing technologies, including laser scanning, but also other technologies like photogrammetry. And we had a very big and large project at TUM funded by the Georg Nemetschek Institute called Automated Creation of Multi-Scale Digital Twins, where 6 different professors were involved, all of them with different expertise, with different field of research, especially with respect to scales. So one researcher, for example, uses satellite radar to capture entire cities. So the goal was to create a system of interconnected digital twins across these different scales, so starting at the city level, then going down into the district level, adding more details, going down into the level of individual buildings, even more details, and finally also including the interior of the buildings. We used all kinds of data for that, with all kinds of resolutions, so as I said, satellite radar, but also laser scans. We used images from facades taken from the streets and more data. The focus here, again, was on using AI, developing AI methods to process the data, because it's really a lot of data, make sense of the data, and also fuse the different data sources. Let's have a closer look on the sensor platforms. I talked about satellites already, so satellite radar was a big source of information here. But we also use conventional data sources like scannings from planes and helicopters. We used our own drones to fly around buildings, capture the buildings using drones. We used mobile laser scanners like the one I'm wearing here on the right-hand side, where you can walk through a building and scan the building while walking. But we also use autonomous systems. And here we see one of the autonomous systems that we use. It's not one of the expensive ones from Boston Dynamics, but it's a system that we developed on our own. So we use this legged robot platform, but on top we have our own computing units and also our own sensors. And we can deploy our own software on the system, which is a big advantage for researchers. So what the robot is doing is it's walking through our building at TUM, and while it is walking, it is scanning the environment. And the result you see on the right-hand side is a point cloud. This is a very good basis for a digital twin, but of course we have to process it. So here we see the entire kind of chain. On the left-hand side, you see the raw point cloud, the input data. On the right-hand side, you see the goal, creating a digital twin, essentially a high-quality building information model. So how do we get from left to right? Of course, we use AI. In this case, AI uses also a lot of domain knowledge, like we as engineers and architects, we know how buildings are constructed. So this is a very good basis for creating also the digital twin. We do a first step, which is called space parsing and semantic segmentation. I will explain in detail later on what that means. The result is partial point clouds of the ceiling, the floor, the walls, and other components. And this result we use then for a second step, where we fit into these partial point clouds parametric building objects. And then we bring everything together and we create the final digital twin, the high-quality BIM model. Okay, let's have a closer look on the individual steps. So the first step is semantic segmentation. On the left-hand side, in the upper part, in picture A, you see the raw point cloud. It looks like a picture, but it's actually a point cloud, how it is captured by the dog or by other systems. In picture B, you see the classification of the individual points, in this case done by a human. On the right-hand side, you see all the different classes like ceiling, floor, wall, and the different colors that have been assigned to the individual points. This is a lot of work. You would not do that for an entire building. if we use AI, then we can achieve something very similar. So in the lower part on the left-hand side, you see what an AI method is capable to do. In this case, we use point transformer, a very capable neural network that is able to classify points in point clouds. And you see these results are really close to each other. So again, it correctly identifies the ceiling, the floor, and the walls, and so on. If we have done this, we can remove from our point cloud everything that we are not interested in. Like, for example, all the furniture we don't care about because it's not part of the actual building. So we can remove that, and what is remaining is really the points of the ceiling, the walls, and the floor. And with this, we can do the next step, and we can fit boxes into these remaining points. This is called space parsing, and we have used our algorithm on different examples. There's an open data set from Stanford that we used as a basis. You see in the third picture from the left the results. So we correctly identified all the different rooms there. And we used the same for our tomb building. Again, you see in the second and the third picture how we identified the spaces, the rooms in our office building. Now you see also the gaps between the different spaces. And of course, in these gaps, there are walls. So we use this information to then fit walls in these gaps. Now we come into a parametric building model, the first step into this direction. We fill the gaps, as you see on the right-hand side, with the walls, but we do the same also for the ceilings and for the floor, adding slabs to our model. This is an optimization step. Again, I cannot talk about the details, but you can always contact me about that. Okay, what you also see in this picture is that we do not yet have doors and windows. The reason is doors and windows are not easy to identify in point clouds because they are pretty flat, actually. So what we do here is we use image information. At the same time, when we capture the point cloud, also images are captured. So we can now much easier see, and the AI can also much easier see doors and windows in these pictures. So we use quite established image-based object detection, detect like the outline of the doors and the windows, and then we fit into our building model, again, parametric objects of the doors and windows. And this results then in a high-quality digital twin, a BIM model. What you see here is on the left-hand side, a laser scan on over 3 stories at TUM, and on the right-hand side, this building model was completely automatically created from this input. So no human effort was necessary. And again, we believe this is a very promising technology. We also teamed up with a company in Germany that you might know, Siemens, because they were very interested in integrating into the digital twin also smaller objects like electrical installations, plugs, sockets, but also fire safety elements like smoke detectors and so on. They are small but very important for the operation of buildings. So there's the challenge, again, to find them in the data, detect them. We solved the challenge, and again, now these elements are also included in the digital twin. We even had a closer look on the labels on these different elements, because the labels contain a lot of information about the type of element, maybe also some ID number and so on. And this is also integrated now in the digital twin. Okay, so this was the second big topic, digital twinning. The third topic I would like to talk about now goes to the construction site. So we have also developed methods for productivity analysis of construction projects. Here we have been collaborating intensively with an association of a large number of construction companies in Bavaria, because they wanted to have a deep insight into their on-site processes, especially with respect to the performance of productivity, quality, and safety. The good thing for us was that they also provided a lot of data because, again, AI methods need a lot of data to be trained and so on. So we were able to install on a number of construction sites crane cameras, thermal cameras, but also laser scans. We could deploy our drones, and we could also use other sensing technology. And we could also use our robot dog. In this case, It's running across the construction site, but not autonomously, because it's a little bit too dangerous for this little dog. You see all the clutter lying around, so we were a bit afraid it would get broken. So in this case, the construction workers actually are steering the robot. But in the future, I'm very sure they will also be able to run across the construction sites autonomously. So while it is walking, again, it is scanning the construction site in this case. So the output of that is something like this. Quite beautiful laser scanning point cloud, where we see in blue, this is the trajectory of the robot, and it captured more or less the entire construction site. So what can we do now with this? What kind of value does it have? Well, we can create value if we now match it against a 4D BIM model. So a 4D BIM model, some of you might know, contains not only the 3D geometry, but also information about when exactly a certain component is supposed to be constructed. So it includes the schedule on a component level. Now we can look at our point cloud and see if an element that is supposed to be there really exists in reality. If not, then we know we are already too late. Then we know we have an issue with the schedule. And you see this here in the practical example. This was a construction site very close to TUM. On the right-hand side, you see the first 4 stories were completed in time. They're displayed in green. But the last 2 then had a big problem. There were significant delays. And this was automatically detected. And this is the big news, that the construction managers can get this kind of information even without being on the site. All right. We now can detect delays, but actually we want to know why these delays happen. So we have to go closer. And in this case, we used the crane cameras and took images from the construction sites across an entire year. We took images every 30 seconds, a lot of data. And again, we used AI to analyze the data. And what we did is we detected workers, not individual workers, but there is a worker, we don't know the name or anything, but we detected the workers using AI methods, but also equipment and other things. And we matched this information about their location against a 3D building model. So what you see on the right-hand side is a BIM model, and these green dots is the location of the individual workers. So we know exactly where they are. This will later help us to assess productivity. But before we do that, we first have a look on the more general aggregation of the data. So what you see here is worker activity over an entire day. So we can easily analyze that. You see that the workers start at 7. They had the first break from 10 to 10:30, a second break from 2 to 2:30, and they ended their work at 5 p.m. Very typical day on German construction sites if you have a one-shift construction site. This is very standard, but now it gets interesting. If you look on it for each and every day over the year, then you will find days where you deviate from these patterns. And then it's interesting to understand what is going on there. So, for example, we found that in April 22, there was a day where there was no activity in the afternoon. So we analyzed the weather data, and we found out there was very high winds in Munich, so high that the crane could not operate because the risk was too high. And if the crane cannot operate, then actually you cannot do much on the construction site, and this is why there was low activity. Same or similar for end of July 22. We had very high temperatures in Munich, around 35 degrees, very challenging for the workers, and we saw 40% less activities. And this is not about blaming workers. No, by far not. It's about understanding why we have lower productivity. So now I come back to what I said earlier. We have this correlation between where the workers are, because we know the location in the building model, and we know also how long they have been active there. Now we can use this information and combine it and take from the BIM model information about what kind of work has been done, and what is the amount of work. So for example, in this case, there's a column. There were workers around this column, very close to the column for 20 minutes. So we assume they were working on the formwork, for example. We can identify how big the formwork is automatically, and we can assess the productivity. To really understand what they are doing, while they could also stand around or do other things, we have to look closer again, and this is what we did here. We analyzed the pose of the workers to differentiate between different sub-activities. Here we used as an example in situ concreting, which is still very common in Germany, that you actually have ironworks done manually and then you pour the concrete. And we focused on the ironworks here. Ironworks itself can have, again, sub-activities, namely layouting and transporting versus actual fixing and securing. If you are fixing and securing, you're typically bending down, and, well, this is exactly what we identify. So we used an AI network, in this case VIT pose, to get the skeleton of the individual human workers, so you can identify if they are standing upright or if they are bending downwards. And this was then used for a classifier as input for a second one, classifier, which identifies whether they are transporting and fixing. And we could show that we reach a very high accuracy in this regard of up to 93%, which is, again, quite good, giving also the very low resolution of the images that we have from the individual workers. So now we have information about the building, the durations, the type of activities. We have to bring everything together. It's a lot of information. So we use a knowledge graph as the basis here. So the knowledge graph represents exactly this, like the activities, the building components, the durations of activities, and so on. And we can use this building graph to then do more comprehensive analysis, like, for example, across different construction projects in terms of productivity, to find out where are the bottlenecks. Why did this project go bad and the other one was good? So this is a very helpful technology, again, something in process, and we will improve this technology further on. Okay, now I'm almost at the end of my presentation, and the final topic I would like to talk about is AI-based construction robotics. So this is a little bit a look into the future. So the starting point here of our research is that we actually see already a steadily growing number of robotic systems on construction sites. They also have an increasing maturity. However, typically they are focusing and built for very specific tasks. Like, for example, one can install tiles, the other one can do 3D printing, the third one might be able to capture information, and so on. So our vision is actually to come to a more comprehensive robotic construction site, where we will have a large number of different types on robots, and they should be coordinated mostly automatically. To go there, a number of things are missing. For example, very detailed planning of robotic construction tasks. We need something like an information backbone to, on the one hand side, gather all the information, provide the right information at the right time to the individual robotic system, and also steer this fleet of robotic systems. And we need to have good concepts for multi-robot collaboration and coordination. And this is what we do in a moment. We have a bigger project across Germany working on this information backbone for robotized construction. It should have BIM information, but also very detailed fabrication information, so the robots can really fabricate the elements on site. It should have information about all the available robotic systems and very detailed information of the individual tasks that the robots have to perform, and also the dependencies of the task, and a schedule, creating a schedule for them. This is one thing, like storing and providing this information. The other big task of the information backbone is to actually steer the robots, sending instructions to individual robotic system. Now start to do a certain activity, like doing 3D printing in a certain story. And we need also sensor systems and get data from the sensor systems back into our system to know something about the progress of the construction site, and also if something goes wrong, because, well, typically things go not always right on construction sites. We used the entire system already in terms of simulation, so simulating construction sites, but in the future we will also use it for the actual execution, and we are already building up a lab using these kind of technologies. So what I have as kind of an intermediate result is this simulation that we see here. It's really a physics-based simulation, so very detailed, close to reality simulation, where you see a robotized crane. So this is not a manually operated crane, but a crane that gets an instruction to transport an element. And you see this little other dog on the ground now moving to the exact position, and in the next step, the crane will lower this element. In this case, it's a formwork element, and then the two of them are actually working together because the formwork elements are quite heavy. Typically, heavy loads are carried by the crane, but the fine and precise positioning is then done by this Husky robot that has a robotic arm on top. So this is kind of an outlook in the vision that we have there. This is under heavy research. We have more than 10 researchers currently working on exactly this concept. What we also do is we train robots using AI. The background is that construction sites are super dynamic. You cannot always program everything beforehand, so you must make the robots capable to handle dynamic situations. In this case, we train them to capture objects in all kinds of poses. So they should very quickly decide how they approach different elements if they see them and have to react to them. We use an AI method here. And the interesting thing is that we can, at the same time, train thousands of robots, and they create in the background a joint policy, a joint AI network that is then being used in practice, deployed on the construction sites. Again, work in progress. It's not final, but I think very promising technology. I could go on for many, many more hours and talk about all our projects, but we don't have time for that. I just want to let you know that there are more projects that we have. Let me conclude. We believe AI has really huge potential also for the AEC industry. We see a large number of different applications for the built environment. On the one hand side, data processing, making sense, getting information from the raw data, let it be images, videos, but also laser scans. On the other hand side, it's a very good tool for assisting also our building designers, getting rid of repetitious work, boring work, so to say, and focus on the really creative part. What we always have to have in mind is also the limitations of AI, in the sense of we have to understand these methods have been trained on training data. So when they go outside of the training field, then they become unreliable. So we as engineers and architects should be aware of that. At the same time, the construction industry is very much invited to share data, because this is also something that our industry is not easy to do, because data is sensitive and it's often protected. But if we really want to do big breakthroughs, then we also have to share data. All right, and with this, I thank you very much. If you want to know more on our institute, please visit our website, and we will later also get involved in the discussion. Thank you very much.
Thank you very much, Professor Borrmann. 이어서 두 번째 특별 강연은 이스라엘 테크니온 공과대학의 라파엘 섹스 교수님께서 AI는 건설 프로젝트 관리를 어떻게 변화시킬 것인가 라는 주제로 발표해 주시겠습니다. 라파엘 섹스 교수님은 이스라엘 국립건설연구소의 소장이자 링 건설 이론을 바탕으로 건설 프로젝트 관리와 생산 시스템의 디지털 전환 연구에서 세계적으로 큰 영향력을 인정받고 계십니다. 라파엘 삭스 교수님을 큰 박수로 모시겠습니다.
Thank you very much. I'd like to also begin by saying a great thank you to Hanmiglobal for to Professor to John Kim and to Gong Li and to all the team who coordinated everything. It's an absolute pleasure to be here once again in Seoul, Korea. This is my third visit. And what I will try and help with this afternoon is, in the short time that we have, to try to link what you heard from David with what you heard from André. I think that David gave us a really, really interesting overview of what industry is doing, what a very sophisticated construction and project management company can achieve. And I'm sure that it seems to me that the partnership between Hanmiglobal and Turner-Townsend is a very natural one. And I'm sure that we'll see many more of those, and we'll talk about that in a moment. And André, as always, I've spoken in meetings together with André many times as guest speakers, but I've also spent much time in his lab. And André, you've given us an exceptional view of the technologies and the really cutting-edge work that you're doing at GNI and at TUM. So thank you very much. I find it exhilarating every time to hear you again. What I want to do is step in between the two, in between the business and commercial side and the very technical research side, to try to link them and to challenge both companies with where we might be going with this and what's the implications. So if I were to, and really the brief for our meeting this afternoon was to try to tell you how might artificial intelligence improve, enhance, support, or optimize construction management. And if I were to do that, I think I could do that quite well. But probably, as most academics would, the first thing they would do would be go to the internet and look for an article about this topic. And I went to the internet and I found an interesting article by Torres and others, which was published in a not very good journal, but nevertheless, and it listed, and they researched different competencies of AI for construction management, as you see. And they listed, I think 35 or something different topics. And these are all the topics where AI could enhance and improve construction management. I would hope, I assume, that within Hanmiglobal and within Turner-Townsend, you're aware of all these different topics. We saw some of them. The other thing I could do, if I were to try to tell you how AI will change and improve construction management, is I could look at our own industry in Israel, and I could give you a list. Here is just a short list of 12 construction tech startup companies that are very active now in the what we call the Israeli construction tech industry, which is distinct from the construction industry. Some of them, like Gender and Bildats and Civ Robotics and Skyline, have their roots in our university, in the Technion. Many of the technologies, one of them here, I missed one, Versatile, which does crane monitoring, something came out of a research project in our lab some 20 years ago as an idea. Gender deal with monitoring people. We saw André's work on monitoring people on construction sites. They do it with Bluetooth, low energy, and with monitoring. And that started from my lab. But they were recently adopted and purchased by Bildats, another company. And Bildats specialize in monitoring construction sites through 360 camera videos. And they've purchased Gender because their expertise is in monitoring what was done, what was the product. They do that very well. And Gender specializes in monitoring the resources that we use to create those products. And you must have the outputs, the products, and the inputs, and if you want to really measure productivity in any meaningful way. And they're moving toward this idea of analysis of what's happening in construction. But all of these are active commercial companies selling services in the market and developing very fast. And that would be great. I had fulfilled my brief to tell you about AI in construction management. So I could say, any questions? But you would ask, I hope, is this really the end of the lecture? Surely there's more to it. And yes, there is. So what I really want to talk about is how might artificial intelligence change construction management rather than improve? In other words, I don't want to talk about incremental change, which clearly is happening, but I'd rather talk about how we might have more fundamental change. And I want to focus, in fact, on the business change, the commercial opportunities that may arise from the technical growth. And one of the privileges I have as an academic is I carry no risk, so I can use my imagination, and we do this on the basis of what happens, and we try to predict possible paths through the future. And if some of those might be interesting, then some of the commercial companies who are here and present might adopt some of them going forward. And so really, I think the fundamental question is not just AI, but how might AI, based on data and information, change our industries? So I'm going to now try and address this question. And because I'm putting a big emphasis on information, I want to define what I mean. I wonder if this pointer going to work? No. Oh, I see what happens. No. How do I undo that? Well, actually, this is fine. Can you bring it back to the original? The first thing we need to do is we need to separate and define carefully, as academics do, what the different kinds of information are that we're using. We're restricted to those. So most of the information we deal with every day as designers is this that's up here on the right-hand side, the PII, or the project intent information. This is information about what we intend to do. It includes things like building information models, BIM models, but it also includes construction schedules, construction budgets, specifications, everything that defines our intent. And we can group that together as project intent information. It's all about the future. And then we use that information to build in the physical world, on the left-hand side, and we use it to control our construction. So we build something real in the real world, the construction site. But then, using some of the technologies that André showed us, and others, we monitor what happens. And when we monitor what happens, laser scanning, Bluetooth, RFIDs, very wide range of technologies, we get the project status information, only about the past. So, and we need to keep these things very separate. And then, of course, we can compare the intent information to the status information. By comparing that information, we can determine whether we're on track or not on track. Knowing whether the workers were late last week or the project was on track last week or last month is interesting, but it's not very helpful. What we really want to do is to learn from that in order to be able to predict, because we want to know what will happen next week and the week after. What happened last week is less relevant. If we can predict what might happen, we can also ask what-if questions and say, if I did such and such change in my production system, changing either the product or the process, then how could I improve? When I could simulate into the future. And if I could simulate into the future and predict, I could make better decisions and improve the way I build. And that really is the thing we want to do. Of course, if we think about, so we have virtual and physical information worlds. We also have status and intent. If we think about the top left corner that I have to touch on, what is our future intent representing in a physical thing? It's a physical model. So if we built a 1 in 50 scale model or a 1 in 100 scale carton model of our building, that's really what it is. We don't tend to do that much anymore because we've become much better at doing it digitally in the virtual world. Okay. So information, we have these 4 kinds of information, 2 of which are in the virtual world, and the intent and the status. And what is their value? Well, information is absolutely key to defining intent because it allows us to move what's in one person's mind into what's in another person's mind and a third person's mind. And in construction, when we have thousands of people engaged in the project, getting the right cognitive model in each person's mind about what it is we want to do and having those aligned is absolutely key, because where they're not aligned, we have conflict. And where that develops into conflict, we have litigation and all the rest. So we cannot build without a mind model that maps to everybody, and technology is critical in creating that mind cognitive image. And where design is unique, all the other inputs can be commoditized. Only the information is specialized. Now that's very important when we think about the value. What I mean by that is, if I can build something digitally very well and refine the information to be very detailed and to have integrity in that model, so all the parts of the model map. If you take the robotics that André showed us at the end, in the end, the robots can implement all of that, or people can implement, but there's nothing unique to what they're doing. The original information is in the design and in the planning, the budgeting, in setting up the production system. Now think about these. We each hold one of these from whatever company, and I don't want to give any company a particular advantage, so we won't mention which ones they are. Doesn't matter. But this matters. One of the companies here that designs the phones creates the information. The second company in the slide, Foxconn, makes the phones. They actually manufacture the phones, all of them. The company that designs them is now worth a number of orders of magnitude more than the company that makes them. The company that makes them has done great. If you think about it, that they've gone from a $4 billion market cap in 2000 to $130 million in 2026. If I showed you only the red curve, you would say, what a great company. I wish I'd invested in that company. But you'd have done better to invest in the blue curve company. And this carries a lesson for us all, that in the information age, the information has value. The products, the physical things, are an extension of that information, and they, as time goes on, carry less and less value. They become commoditized. So where are we in the construction industry when we think about this? Well, with the introduction of building modeling, as an aside in parentheses, both Gong and I are students of Chuck Eastman. We worked with him from 2000 to, well, really until the end of his life, in trying to develop the concepts and ideas of building information modeling. And so we breathed and knew this from that time and tried to predict how quick the adoption of BIM would be throughout the world. And we assumed, by we, you, I, and many, many other people, that the digitalization of the industry would follow, that design information would be generated using BIM. BIM models would completely replace traditional drawings and plans, that standardization of information would allow a lot of automation, and then eventually it would drive procurement, contracting, and purchasing. BIM models would be used for construction, and productivity would rise. But the reality is a little different. And although there are all these different technologies, this is not new, and this is from a number of years ago from Boston Consulting Group. Many, many different technologies, but they're all developing slowly, sure. There are companies now that do many of them, but there's not been the major revolution and change that we expected. So organizations using 2D and CAD are still very common. The pace has been very slow, and BIM and AI have not yet resulted in measurable improvements in construction productivity. That might be because it's hard for us to measure, but we had a piece of research recently which tried to, over 20 years of monitoring of construction projects, to determine what's the delta in productivity as a result of adoption of a wide range of technologies. It really was very difficult to find the right measure and to find something that really changed. So you might say that so far, digitalization has occurred within existing business structures. And revenue models have basically remained unchanged. We still basically see architects and engineers designing. We see construction management companies doing project management. We see in different countries, in different cultures, people doing quantities. We see different people doing contracting. Then we see general contractors, specialty trade contractors, fabricators off-site, different supply chain actors, regulators, permitting agencies. I mean, but really none of it has changed in terms of structure and place of people in the market and how they perform together. And that raises some questions. Are there problems with the technology? Why have we not seen, for example, in other industries, you saw major changes in productivity. In the music industry, in the communications industries, entertainment, automotive. A car factory today looks nothing like it looked 30 years ago. And the number of workers there have reduced radically, drastically. And that's the case in many industries. So if it's not a problem with the technology, which clearly we have challenges, but we're not using technology that's so different from others, are there problems with our business models? And are the business models built in the right way, or are they structured in a way that can engage the technologies in a way to let them create value and have that value be such that we can replace people who are not productive? So the question is, can anyone then profit from the productivity gains? Because if they can't, then they won't happen and we won't be able to measure them. This brought a colleague of ours in Finland to suggest that there is opportunity, perhaps, or threat, depending on how you see this, in the construction industry for something called creative destruction. Creative destruction is the idea that technological advances give rise to new types of companies with new business and revenue models because they improve total productivity across the whole chain. And they require fewer inputs or they provide greater outputs, one or the other. And they enable someone also to profit from the process. Now, I mean, we think of commercial sales. Amazon, as an example, has really completely changed the way that we buy things or sell things. Zoom, as a video conferencing software, and others like it, have completely changed the value of office real estate. It's just different to what it was. And these are new companies that have nothing to do with renting retail space or retail or commercial space for shops or office space for workers, but they've completely changed those businesses by providing those services in an entirely different way. So what happens? New technology is invented, a new business and revenue model is developed. What happens is that old technology is made obsolete, of course. The old businesses find it very difficult to adopt the new technology. And so those new companies must develop their own new business models that work with the technology. Those companies can arise and grow. And in the end, we have bankruptcies or some survive and transform. Just to pay credit where credit is due, the term itself, creative destruction, is associated with Joseph Schumpeter, who was an economist. He wrote a book called Capitalism, Social and Democracy, and as often happens with these things, the ideas were fairly old. They're not new, but they become more and more common as time goes by, and the book was reprinted in '76, and since then it's been much better understood in the digital and technological age as describing what can happen in our industries. So creative destruction is a process in which new innovations lead to new organizational structures and business processes as existing technologies and business processes and systems that evolve to apply them become obsolete. Now, what I want to suggest going ahead in my talk is that we need to think about new ways of adopting the technologies in ways that we can bring profit or value directly, but that might not work with the siloed professional approach and commercial risk approach that we have in our current industry. So I want to bring one example, which is digital twin construction, as a conceptual way that a set of technologies and how they work together, not as a single application, but a set of applications, and how they offer an opportunity for new business models. And whether that leads to creative destruction or to transformation of existing companies is largely up to you rather than to me. So I will try and say what it is its value, and perhaps how it's monetized. Now, I realize that I have a little bit more time than we thought, so just bear with me for a moment, because I want to give you just a piece of background, which I think I have here. We'll just reveal all the stuff. Apologies. What I want to do is show you where this comes from. And where it comes from is some of the origins of digital twin construction. We worked in the mid-2000s on the ideas that we could bring lean construction and building information modeling together. we started with the idea that this could be used to enhance productivity on construction sites by providing construction managers with situational awareness. So the idea was we could monitor what's going on through the system and then present it to workers and to project leaders in a way that easily could communicate to them where they should go next in order to be most productive next. And we built prototypes of these kind of things. Second prototype of an information system, this was already 2011 or 2009. And the idea was to say, for any given piece of work, any work package, we could communicate to workers and teams how mature that next piece of work would be. Was it mature? Were the materials ready? Was the information available? Was the space clear for them? And we could give them with a system of stars what the priority was in any particular given region. And that developed further into a second prototype, which was then tested in a number of construction sites. And that led afterwards to a startup company that works in production control, planning and control, with screens and so on. It's a company that still continues to function and work very well. I believe they work a degree with Turner&Townsend in Heathrow and in Hinkley-C, together with Laing O'Rourke, but that's a whole other story. But from those origins, and with your indulgence, I'm just going to go back and show you here what this digital twin construction has developed into. Oh, sorry, I should have set this up before. You can see that I need AI help. Right. Okay. So, digital twins. So, what is digital twin construction? Now, based on those ideas that we could guide workers and guide crews to where they should go to be most productive, we adopt a paradigm from manufacturing and from aerospace called the digital twins. And André talked about this to some extent. But digital twins really is a paradigm that goes beyond the status information that I showed you before, because we want to monitor the site and we want to build a digital twin representation of what's being done. That's one part of it, but the other part of it is beyond the monitoring, we'd also like to operate the system. And by operating the system, what I mean is we want to direct what happens in that system. So we have an architecture for a digital twin construction system. And the architecture consists of the following things, along the lines of the information I showed you before. So we have at the top a BIM model that describes the product and the process that we intend to do. We use that to build the physical building, to tell the workers what to do, if you like. We monitor what goes on. We get the raw data that you saw, the laser scans, the images, the RFID tracks, the Bluetooth tracks, the scanning, and whatever, photogrammetry. The first thing we have to do, and this André tackled really well in terms of seeing how the workers do, is we have to interpret that information and merge it with the BIM models and everything else to be able to build our status model, which describes our as-built product and our as-performed process. And then we have to use some more intelligent software to evaluate conformance, to tell us what's been happening, and then that drives prediction on the top left, predict performance, what will happen going forward, use that to advise people how to plan and design the next cycle, and feed that back into the BIM to direct construction. And that closes a cycle that we call the plan, do, check, act cycle. And if we can do that relatively with low latency, meaning with short times, then we can really impact what's happening in the site or in the design process. And we can see how that flows through. In a nutshell, and again, I could describe this in much more detail, this is the concept of digital twin construction. So if we think about this, then there are a number of applications of AI that we need to make this happen. In the first instance, for the design and the planning, we could be using generative design, semantic enrichment of the information using deep learning and machine learning. Again, some of the ideas where we saw AI being prompt-driven design of buildings. But there are many ways to do this, and even in industry now, generative design is becoming very common. I know that Professor Lee has been engaged in this for a long time and very actively. So these things are developing. They are large, much of it's available, much of it is becoming much more sophisticated very quickly. The second place for AI is in the monitoring of data from multiple sources to intelligently build a full picture of what's going on. And here too, you saw examples in all both the presentations, but especially in André's, of how this is being done and how it's being facilitated, and there are also commercial opportunities for this. And the next thing is we need to evaluate conformance to design or to process. They could use LLMs, but there are other tools to do this too. And this too, this is a much harder nut to crack in my view, but it is being done as well. I think some of the things in your Hive system, David, are beginning to help people do this. And then we want to predict what will happen into the future. Again, we can base it on learning, on deep learning, on all sorts of things. We have used in the past simulations, agent-based simulations, which works very well, but I think nowadays we can go much faster than the agent-based simulations with learning, with machine learning. So, okay, I ask you to indulge me and make a leap of faith that this can be done. If not today, then tomorrow. Soon. But what's the value of it? Well, there are three aspects to the value, how we can get money from this. The first is that what we're doing is we're implementing a plan, do, check, act cycle. So if we can optimize planning and control, we can simply do better than we do today. If I can figure out that doing the flooring in a particular apartment tomorrow is more valuable to me than to do it in some other apartment, because in this apartment I can run through the whole process, get to a milestone, finish, and be paid by the client, then that's maybe more beneficial for me for my cash flow than if I do it in some other apartments where the work is not mature, will not lead to a milestone. If I'm building a nuclear plant, there might be a long supply chain of materials. I need to work in the areas where all the supply chain is mature and can deliver me the materials, rather than work somewhere else where I'm going to run out of stuff and then my workers are going to be idle on site for a few days. So there are all kinds of optimizations. The next thing is we like to do global optimization rather than local. Our current business models are aligned such that we may have a manager, we may then have a designer, a general contractor who wants to do some work on site, but they're reliant on a prefabricator off-site who's reliant on a designer further down the supply chain, and every one of them can optimize their work, but their optimization functions are different. A precaster might want to produce all the pieces of a certain size, because that's efficient in terms of not reconfiguring molds. But if they did that, then we'd have nothing to erect on site until everything was produced. We can combine those optimizations to be global and get global optimizations, which always are going to be better than the sum of any local optimization. And the third value we might be able to get from this is that we might be able to step down the road toward automation. Now, you can think of this in parallel with self-driving cars, which we see creeping onto our roads every day, more and more, practically speaking. But in that automation, we see that in the beginning we have humans deciding everything. We then move to situations where humans decide, but machines advise. You can imagine a digital twin construction platform where the platform does the predictions, does the simulations, and says, I recommend that tomorrow you focus on the work in this area, or that zone, or next month, or next week. And then human can judge and decide, good idea, bad idea, whatever. But then we might move to a situation where the humans supervise, but we let the machine decide. Now, many of you will use navigation systems in your car. Most of the time, the system is telling you, I recommend you turn left, turn right, do this, go travel there. Now, you might think that that's human decide, machine advice. But most of the time, because we as humans are lazy, we follow the advice. So fundamentally, we're in human supervise and machine decide. Because sometimes we might do something else. But that's only a step from automated decision making where the machine can actually do it without us. So there are these, I want to check those three things. And we ran an experiment at Tekhnion where we tried to set up a construction environment with digital twin construction that we could test these questions. And so we set 5 levels of automation, of autonomy, from humans doing everything on the left to AI doing everything on the right. And that relates to information acquisition, analysis, decision selection, action implementation, and so on. And those 5 steps are what we implemented in the experiment I will show you now. Yeah, fantastic. So we with collaborators in a project on digital twins in which TUM were also a member, and we were a construction company in Finland, in Helsinki, provided us with a time-lapse movie of this building. The building was built, a precast residential housing building, built in 5 months. And what we discovered from this building was that actually the priority for the general contractor was to close apartments so that they could have finishing trades begin work. And you know the weather in Finland, I guess it's not that different in Korea. Nice and sunny, nice and shiny, sunshine in July, but come October, you cannot work on the site unless you're indoors and closed in. So absolute priority for them was to close individual apartments. So that drives the optimization for the general contractor, but that's different to the optimization for the precast director and very different for the precast supplier. So on the basis of this building, which, yes, great, we put together in our laboratory a model building. It's 1 in 25 scale. And we made it from pieces of wood that were laser cut with plastic pieces that represent the concreting and the supports and so on. So we had 2 construction teams. And we built around, on the left, you see the building, the assembly worker, the concrete worker, the manager, the suppliers, and so on. That's the physical environment. But we were able, in the laboratory, to add on the right-hand side a digital twin construction system. We had cameras to monitor the work going on with identification of the workers. We had QR codes on the pieces to monitor the flow of work, and so forth. And then we had recommendation system, simulation system, and so on for the manager. And the focus of the research is the manager. So here you see the construction site. Before it begins, they're all waiting. And now they're building. Now, there is the factory, there is the concrete worker, and there is the precast erection worker. And the guy who comes in every now and then with the paper is the construction manager. And the manager's responsibility is to direct them. Erect here, erect there, do this, do that, do whatever you're doing. And it takes between 3 and 4 hours to build 2 stories of this building. So we won't wait the 2 hours. And we're testing 5 different levels of automation for the manager. We're measuring what the manager is doing. And here are the results. We run this experiment many, many times, 35 to 40 times. What I'm showing you here are the results for 5 degrees of autonomy, from conventional, no help from the AI, the person does everything, to on the right-hand side, an entirely digital twin-operated construction. And what you see is the curve, the dotted black curve is the target. This is what is in the contract. The contract says you must deliver 2 apartments every 5 days. A day in the experiment was 8 minutes. And so none of them meet the curve, but you can see on the conventional that every project manager is a different person, a different human being. So they all tackle the same problem. They're all experienced managers. And you see they tackle it in different ways and they get very different results. We introduce errors. So every 5 or 6 times during the production, there is a piece with an error. It has to go back for quality control. There are changing conditions. So they have to respond to what's happening in reality. You see that when we introduce the state-of-the-art, that is, we give them the situational awareness like we had in our experimental prototypes 10 years ago, they got worse. Their performance was worse. Why? Because they were spending too much time working with the technology. They were spending time looking at the screens, figuring it out, trying to second guess what was going on. It was quite taxing for them. Their cognitive load was much higher than if they just looked at the building. But when we began to show them actually what was happening on the construction site as a digital shadow, they stopped coming to the site. In other words, now they sat by the computer in the other room watching what was going on, and they could see live where it was, and they could decide things. They got a little bit better, not much. But then when we added in the simulation, optimization, and recommendation, they began just accepting what the computer suggested, because the computer could predict thousands of opportunities into the future and choose the best and say, do this. So like you guys in your cars, they just followed the Waze or the Google Maps, and it got much better, much, much better. And in the fifth round, we simply had the software do it without them. No manager present, only the workers. But the workers throughout every one of these were getting their instructions through their phones or through their screens to say, do this, do that. That was the mode of communication. So for them, it was actually, and we asked them, much more relaxing when there were no managers running around them. They could just get on with it and do the work. You can see it here in a different set of numbers. It doesn't matter what the units of the cost are, but you can see that the improvement is steady and gradual and consistent. That once we let the machines optimize, we can just over time get better results. And then we did something more. We asked ourselves the question, if we optimize for the factory separately than for the site, what results do we get? We got one set of results, which is in blue. And then, in red, I apologize, in red. And then we said, if we do a global optimization, how will that change things? And you see the difference. The blue lines are for the globally optimized solution, and the reds for the locally optimized. And the difference is stark. It's that they're more consistent and they're superior to the others. They're more predictable. So the question for us as researchers in the laboratory is, can we replace this? And this is a production control room from Mace. You'll be familiar with the data center project. But just to make and this is 10 years ago, but just to make the point, might this be the control room of the future? Maybe. At least for production control. Now the question is, if there is value in this because of improved productivity of planning and global optimization and autonomy, how do we monetize it? That's not the same question. Well, I want to suggest to you 3 different ways. The first way is production control and construction as a service. If I were to set up a startup company with the idea of making an exit in 10 years and earning a lot of money, I might say, let me prepare a software with technology systems that exist, and I can offer a service to project management firms or general contractors who manage production day-to-day on-site and off-site, and I could do that. There's a great business opportunity. We could make an information and control platform, sign up people to the platform, it can run their projects for them, provide all those 3 values that we talked about. And so it might look like this. If I superimpose this on the digital twin construction paradigm architecture, we will still have architects and engineers. They will use BIM and so on. They'll create the as-designed information. Then we'll have a construction project management company. We'll have general contractors and trade subcontractors. And then there are construction tech companies who provide you with laser scanners, drone service, 3D photography, all these things, wonderful things. They bring them to the site, they get all the information, and it's great, but what do you do with the information? Well, we could feed that into a digital twin construction platform, and the platform could do the optimizations, recommend what you should do, and everything's great. Well, I assume you could earn some money doing that. It would be quite an effort, but what I want to suggest now is this is the old way of doing things, because it's still rooted in a paradigm of construction that we already know. And we asked the question at the beginning, is that really practical and is that working for us? And I suggested that there might be paths that follow creative destruction to do something else. And the something else looks like this. We don't want the local optimization. We like a global optimization. So we can observe that if we create a service where we not only tell people what to do, but it's often like this. if I think I can do something better than you, I can tell you what to do. You might adopt it, you might not, that'll be fine. But if I put my money where my mouth is, so to speak, then I should be able to do it instead of you, better than you. And then I can make a lot more money. David, you mentioned in your talk that you had, if I remember the numbers correctly, $7.69 billion turnover. But later in your talk, if I remember rightly, you said something like you were delivering $3 trillion of projects. If I work that out, it's about 0.3% turnover on a huge turnover of the actual projects. Why would you, now I don't really mean this, but you could think to work on the 3 trillion rather than on the 7 billion. It's 300 times more. So if I could say, I can do this better than you, well, I can do it. There is a company in Finland who have adopted this approach, and they say, we will bring you, they've designed the software as a service, but they say, we'll go beyond. We'll bring you the workers and we'll do the work, because we can do it better. But then we make another observation. Every project that you run, small or big or whatever size it is, looks like this. You have the project, but you have a whole supply chain around you of designers, of contractors, manufacturers, fabricators, interior architects, I don't know what, everything. But they all are serving many projects in parallel. It's very common that a project will be dependent on some designers, suppliers, supply chain, precast factory, but those people are serving many projects. And who they actually work for, I mean, day to day, probably the ones who shout loudest or sue more frequently, or I don't know what, or find the ways to bring them to see the world they want them to see and then provide the work. But there is an entire ecosystem around every project. And wouldn't it be better if I'm running a software as a service or a platform to run more than one project? Obviously, I would. I would anyway be running more than one. But there are economies of scale in terms not only of purchasing materials like concrete, but in terms of managing work. If I want to get high productivity from crews who are doing flooring or electrical work or something else, there are natural cycles of more work and less work in each project, but if I could optimize them across an economic zone, I could make a lot more money. A single project is dependent on design information, materials, resources, and so on. But there are many projects in the real world. We tested this, and we call this the PPO model. So there are not only operations and trades, there are not only locations where they work, but those fit into projects. And companies have portfolios of projects. Now think of the bottom on the left, the operations, those trades, the work in multiple projects. So if I close the circle, I can optimize the trades across the projects, across the portfolio, rather than within my single project. So instead of having the single project silo and thinking of a project manager who does this, let's think of this as a broader system. And we can only do that with information and AI, because we can't control the information. One of my students did a model of Newark, New Jersey, 2 different counties over 2 years. On the top is it's a simple representation of many construction projects. Each project has X numbers of apartments on a floor and Y numbers of stories in the buildings. And down below are the resources present in the Newark, New Jersey construction area. And when you run the simulation, then it's an aging-based simulation, and you run it through. Okay. And you can immediately, you can work out that by improving production control at any given site, you can attract the labor better, and good feeds on good, bad feeds on bad. Sites that are managed worse have much more difficulty getting labor and materials. Sites that are managed well and consistently, workers want to be there, subcontractors want to be there because they can make more profit. And so that brings me right to the end, which says if I have a service like this, obviously I can serve many projects. And then if I do all the construction management and processing and so on, well, of course, there will still be architects and engineers, and there will still be general contractors, because I don't want to adopt the risk in the projects and many other reasons, which we won't go into right now, but it could look like this. And that's a much more powerful business paradigm. And so what I'm suggesting is it's worth thinking about AI and data and information impacting on our industry in ways that allow us new opportunities, that rather than being king of the old world, we'd rather be kings of the new world. And if we're to do that, then for companies like Hanmi Lean, BIM, and AI offer great opportunity because your company has within it knowledge workers, information workers, rather than construction workers. Your work has value. The other work can be commoditized. So why not get the profit from all of it rather than just from the information piece of it? So project management companies with professional staff, sophisticated information tech and processes, and access to capital are uniquely capable, in my view, of providing DTC platform services and later to grow to perform the DTC itself. You don't have to directly employ all those workers, but you need to much more tightly control them. And so I'll finish there with that thought.
네, 그럼 지금부터 AI 시대의 PM의 성장 전략을 주제로 패널 토론을 시작하겠습니다. 토론을 이끌어 주실 좌장님은 연세대학교 건축공학과 이강 교수님을 앞으로 모시겠습니다. 큰 박수로 맞이해 주시기 바랍니다.
Hello everyone. We are going to have a panel discussion session. And since we are running a little late, anyway, this session will end at 5 p.m. as promised. So we'll probably run a little bit faster. The overall topic of this panel discussion session is AI in the era of engineering and project management. I'm the session chair, and we have 6 panelists, including the 3 keynote speakers, Rafael Sacks at Te크nion Institute of Technology, and André Borrmann from the Technical University of Munich, and David Whysall from 터너앤타운젠드, and we have 3 more panelists, the Professor Changbom Ryan An from Seoul National University, and thank you, and Dr. Buyong Jung, Vice President and Head of AI Transformation at 한미글로벌, and Dr. Kyung Lee, Chief Information Security Officer and Vice President of Po스코이앤씨. We have collected a set of questions from audiences, while you're registering for this event. And I compiled them into 5 topics. Actually, all of them are very good. By good, I mean very challenging. So the first one deals with the people issue. What should be the role and the job functions in the AI era? The second and third one deal with the data issues, company-wide data issues and industry-wide data issues. The fourth one deals with the management issue, how to measure the impact of AI and AI adoption. And the fifth one deals with the legal issues. Due to the time limit, we have 6 panelists for 5 topics, and we have only less than an hour to discuss this, so I'm going to ask only 2 or 3 panelists to answer some of these questions, depending on their expertise. So the first question is about changing PM roles and job functions in the AI era. And this is, of course, very difficult question to answer. And also, there are multiple issues. The first one is the question at the organizational level. So whom should we hire and what should be the role of PM organizations, and how should we train people to become an AI expert? And nowadays, companies are not hiring newbies, new graduates. They want to hire experienced people. And in the AI era, I think it's a global syndrome across all domains. So then how should PM, especially PM companies and construction companies, prepare for this? And another thing is the individual person level. So at an individual person level, how should we prepare for the AI era as a project manager or construction engineer. So I'd like to throw this question to Rafael Sacks and David Whysall. So who should? Okay, David Whysall, could you start first?
Thank you.
And also Dr. Buyong Chung.
Okay. Can you hear me okay? Is that all working okay? Thank you very much. Thank you, Rafael. Firstly, we are, Townsend, taking on lots of graduates still. So we think the answer is doing both. It's retraining, it's working with technology, making sure it integrates into our people strategy. But we are really committed to making sure we continue to invest in early careers, professionals, graduates, interns. It's very, very important for the business longevity. I think I mentioned, our strategy is technology plus people plus knowledge and data. We don't see technology substituting people. We see it supplementing, actually, our people. I think it's a big part which is around leadership. So we're spending a lot of time with leadership to equip them to really understand AI, not be scared by it, embrace it, be AI literate, we talk about, and making sure they are the catalyst for getting AI right. So we've launched a lot of AI tools just to our very top senior people, 200 people around the world, partners, to trial, to test, to learn and educate, so they can start to be the ambassadors of using it going forward. Alongside that, into the areas of kind of technical disciplines, risk management, procurement, contract administration. As I said in my presentation, we're looking at the areas where we can enable automation, and we want to get automation to unlock capacity of people to think more, use their brains to think value, think beyond. There is a point in certainly major projects where it can be fairly repetitive. So how do you unlock capacity is what we think about, and the capacity to do more valuable things going forward. So that's what we're kind of focused on. I think, from hand over to Rafael, what Rafael talked about there, and I mentioned in my presentation, we're training our people to go deeper. What I mean by go deeper, to understand supply chains. So we believe we can unlock productivity, performance from deeper within supply chains. So whereas previously project management firms have operated above supply chains, we've got to vertically integrate in supply chains. So we can get our people to understand that, go deeper, and really understand the depth of how supply chains work, alongside retraining with technology and AI. I think it's very powerful.
Great. Rafael?
Very briefly, I can relate to this perhaps more as an academic and a professor than as an practitioner. One of the things that we see happening in many professional disciplines in construction, both architecture, civil engineering, structural engineering, and others, is that the length and the period of training is becoming longer rather than shorter. In our university, we offer a 4-year degree, a Bachelor of Science in Civil Engineering or Structural Engineering. And we used to offer, until recently, a 5-year bachelor degree in architecture. Well, the architecture degree is now 6 years because they've decided, and I think quite rightly, that the master's level should be added in as an entry level. And so now, despite the fact that many other colleges are offering 5 years, we offer a 6-year degree in architecture. And we see it across Europe. There is something called the Bologna Protocol and others where engineering education has changed from a 4-year degree to a 3+2. And I assume you have this at TUM, where you have 3 years and then 2 more years of master's training, of master's degree. And more we see professional organizations and government regulators requiring the 5th year, the master's degree, for registration as engineers. And I think that that's necessary, and I think it will become more and more the case, because as we use tools that are more sophisticated, we need people who not only have experience, which unfortunately, they can't really get in the universities. But people who are able to think more analytically and more wisely. Now, using AI during university careers to summarize material to think does not encourage critical thinking as much as it might. And so we need to find, I think the biggest challenge for the construction industry is actually in the universities and others who are training professional people to be able to produce people who can still think, read, summarize, because that's the only way that when they get the exposure to construction, get the experience, work with people, work on machines, right, then they're able to take AI and use it and still have control, rather than surrender control. And we recognize that people are lazy. All of us are lazy too. So whenever we're offered help by an AI, chances are we'll use it and we'll abuse it. And because mostly it'll be right, that'll be fine. But the challenge is when it's not right. And if you want to think about that critically, you can start with construction safety. And we know by now that statistically speaking, self-driving cars, autonomous cars, are a lot safer than human-driven cars. And where does that leave us as professionals? And how will we deal with those situations? So we will need people who can devise systems, manage systems, production systems, rather than manage the production itself. And those are different skills. And I'm not sure, I don't know yet how we train for that, how we, in-house or in academics. I think we probably have a lot to learn still going forward and a lot to research.
Yes. Okay. After Young-Jung.
I don't know which language you should prefer for all of the audience, but
I mean, whatever you want. We have a translator. So.
No, okay. I just prepare the answers exactly your questions right there. So I believe that the PM organizations will not be replaced by AI platforms like Gemini and ChatGPT. Instead of that, the conventional PM companies like experience-based PM companies will be replaced by AI-native PM platform companies that our company pursue, which combine human expertise with strong data infrastructure. So regarding that, the risk of subordination, if PM firm act as a passive consumer, like just using AI model without strong data infrastructure, there will have a big risk in subordination. But if PM company has strong structured data and with strong data governance, it will not have any risk in subordination. So maybe it become unique strengths the competitors cannot copy. So the first answer is right there, and second answer is just related to PM roles, right? So I think PM roles can be changed in the AI era because now the AI is changing everything in the world right now. So my perception in AI is that it depends on how companies use AI in their jobs. If companies just use AI simply just using just asking questions and getting answers, it's just they will fall behind. But if the companies just re-engineer their process, they will have a big advantage in AI era. So I think in the AI era, the concept of PM role will be changed, right? From experience-based PM project management to data-driven and predictive project management in this area.
Okay. David, do you think the role of the PM organizations or companies or consulting companies, firms, be the same in after or in this moment, or do you think it will be the same?
I think they'll have to adapt. I mean, like I said, I don't think you'll see a day where technology companies deliver projects, but I think it's how project management companies adapt. And I do think project management companies that don't adapt by embracing technology and AI and allowing that to, as I've said already, unlock visibility of performance into supply chains. Otherwise, there is a risk that, project management companies that sit over the top of supply chains become redundant, not required. Because I think you'll get to a point where clients can access technology, probably the GC, the main contractors will provide more embedded information. So the kind of executive project manager, what are you there to do? If you're there to drive an outcome, more value, better performing projects, you've got to vertically integrate, you've got to get into a supply chain. So I think those that don't adapt might not be around. Those that do adapt, there's the backdrop of huge major projects around the world, as I talked about. And there's a lot of growth opportunities there, I think.
Okay. Thank you. I really like the dichotomy of experience-driven or based project management versus data-driven project management. And actually, that's a good lead to the second topic, company-wide data strategy and asset development. So now we know that we have a lot of data, but IT information experts will say they are not really data, they are garbage because they are connected, they cannot be processed, machine processed. So we'd like to achieve the data-driven engineering or project management, we need to connect them together, and also we need to compile them in a form that machine can analyze. So I'd like to ask André Borrmann and Puyong Jung and Kyung Lee about how we should be ready to, or how should a company to compile the data, and which types of data should be collected first, because we cannot collect everything at the same time. And how can we achieve competitiveness, AI competitiveness, by doing so, by collecting and analyzing company-wide data?
Very important question and super relevant. As I said in my talk, AI does only work if you have data, and it does only provide meaningful results if you have data. So you should really use the data that you have. I would say in most cases, it's not so much about collecting. The data is already there in most companies, but it sits there as kind of a treasury that is not really used. So there are all kinds of data, and you're right. Most of the data is unstructured, and we always speak about getting from the data to information. So maybe a simple example: all the emails that we write and receive, they contain already a lot of management data. But of course, it's raw text. Now, converting that, for example, in something like a knowledge graph, can then suddenly make information available. So that would be an easy example, like a low-hanging fruit. You have already these emails. Why not send an agent across all the emails, gather the meaningful results, and create a knowledge graph out of it? To be honest, I have done this with my emails over the last weeks. I really now have this knowledge graph where I have all kinds of persons and projects and know how they are connected. And now I can use large language models with this kind of knowledge, and they will provide me much more insightful information. So this was one of the many examples. For construction companies, all of them have these kind of surveillance cameras for security. But of course, this is also rich information for, let's say, project information. Of course, you should have the option to translate the data, to process the data. This is a little bit more difficult. It's not as easy as just analyzing the emails. But of course, the construction companies should go this way because then they understand their projects much better, as I actually discussed also in my talk. I have another example from a number of Bavarian engineering offices. They teamed up and analyzed their drawings they have from past projects because they know this is actually how we work. If we create a new project, then we look in our storage about the old drawings to learn from the old projects. Now they digitize that. They create knowledge out of these old drawings, and then they have a good knowledge base that they can use for AI for new projects to get recommendations. And there are many, many more examples like this. So first, it's not so much about collection of data. Data is mostly already there, but processing it and making information and knowledge out of that is a big chance, and I think everyone should do it. Each and every company should do it.
Can I interpret that as instead of focusing on the data, first focus on the use cases first, and then try to utilize existing data you already have, or something like that?
It's a little bit a hand and egg problem. So sometimes use cases pop up if you then have like your better structured information sources, knowledge graphs, these kind of things, then suddenly you find out that you can do much more. So maybe don't wait until you find a use case before you make use of your data.
Okay, great. Can we go with the 이근영 부사장님 first?
저는 잘한다고 해보니까 잘 못 알아듣더라고요. 몇 번 해보니까 그냥 한국말로 하도록 하겠습니다. 두 가지를 좀 말씀드리고 싶은데요. 하나는 그 생성할 때 데이터를 만들 때 활용을 좀 고려해서 만들어야 된다는 이슈가 하나 있고요. 하나는 또 그 만들어진 것들 만드는 데이터 생성하는 이해관계자가 있는데 그 사람들이 실제로 나중에 활용하는 거에도 도움이 되어야 된다. 두 가지를 말씀드리고 싶은데요. 첫 번째 건 어떤 것들이냐면 예를 들면 시공하는 현장에서 시공하는 회사에서 되게 많이 하고 있는 것들 중에 하나가 PDF 도면을 AI를 이용해서 인식해서 변환하는 것들을 많이 하고 있습니다. 생성할 때부터 PDF로 만들진 않았을 테니까 모델링 툴을 제대로 사용해서 뒤에서 활용할 수 있는 정보들을 제대로 넣고 그것들이 이건 뭐 우리 보호해야 되는 거니까 니네는 원본 파일이 아니라 그냥 무조건 PDF로 가져가가 아니라 그런 것들이 온전하게 BIM 설계든 앞에서 생성된 데이터들이 온전하게 뒤에 후속에 다른 조직들까지도 활용할 수 있게끔 그렇게 논의해서 진행하는 것들이 첫 번째 이슈일 것 같고요. 두 번째는 생성하는 사람들이 실제로 다시 활용할 수 있어야 됩니다. 두 번째 예는 이제 현장의 예를 좀 들고 싶은데요. 프로젝트 현장, 시공 현장에서의 대부분의 데이터들은 대부분 다 협력업체가 활동을 하면서 이루어지는 데이터들이 많이 있습니다. 대신 그런 것들이 회사 차원에서는 수집이 다 프로젝트 직원들이 입력을 하는 그런 상황들이 많이 벌어집니다. 그래서 그런 것들을 협력업체 회사에서 실제로 오늘 몇 명이 나왔는지 어떤 직종의 사람들이 얼마나 작업을 했는지 그리고 이거 하는데 돈이 얼마나 들었는지 이런 것들을 제대로 입력을 하고 뭐 지금 제가 말씀드리는 게 대부분 다 작업일보에 대한 데이터들인데요. 그런 로우 데이터들이 실제로 협력회사에서부터 취합이 돼서 그 데이터베이스로 연결이 되면 훨씬 더 로우 레벨의 데이터들이 제대로 모아질 수 있을 겁니다. 이럴 경우에 실제로 나중에 협력회사 대표들은 회사의 규모 때문에 IT 시스템이나 AI 시스템을 만들지를 못합니다. 그랬을 때 제너럴 컨트랙터가 만든 플랫폼을 같이 활용을 할 수 있게 해주면 내가 우리 직원들을 몇 명을 보냈고 생산성이 얼마나 됐는지를 그 플랫폼에서 같이 활용할 수 있다면 입력하는 데이터들도 더 정확해질 거고 더 정확한 데이터를 입력할 수 있도록 독려를 할 거고 그런 것들이 나중에 AI를 활용해서 분석이 되고 예측이 될 수 있는 그런 데이터가 모니타이즈가 될 수 있게 하는 기반이 될 거라고 생각합니다. 이렇게 두 가지로 좀 말씀드릴 수 있겠습니다.
You briefly mentioned about the security issue, information security issue, and actually this is my first time to see Chief Information Security Officer, and I think that's a very pioneering job title and role. And as a Chief Information Security Officer, I totally agree with you that we should open the data as much as we can, as far as we don't have any security issues. So, as a Chief Information Security Officer, how much can we open, or what might be the guidelines for opening a certain set of data versus not opening a certain set of data? Sorry for the difficult question.
네. 제가 작년까지는 AI 조직을 맡고 있었고요. 그래서 저희 회사의 AI 프로젝트들을 리딩을 했었는데 올해부터는 또 정보보호를 하게 됐습니다. 작년에 제가 제일 불만이 정보보호 조직에 대한 불만이 제일 많았습니다. 이것 때문에 하면 안 된다, 저거는 안 된다, 이런 것들이 많았는데요. 지금 와보니까 충분히 다 이해가 되더라고요. 그래서 이런 것들은 하면 안 되겠구나. 그리고 더 올해 들어서 더 제가 제일 신경이 쓰이는 것들이 바이브 코딩 때문에 엄청 신경이 많이 쓰입니다. 모든 직원들이 AI 프로젝트를 하면서 AI를 자기의 툴로 만들어서 사용하는 것들이 가장 큰 이슈 중에 하나고요. 그래서 저희 회사는 저희 회사도 만들어가고 있고 고민 중입니다. 그래서 그런 것들을 좀 말씀드리자면 각 개인들이 만드는 것들은 열심히 독려하고 데이터는 본인이 가지고 있는 데이터들 가지고 일단 바이브 코딩은 충분히 제일 쉽게 할 수 있게 한다. 하지만 그것들이 부서를 넘어가거나 전사에 를 넘어가지는 못하게 한다. 그래서 그런 필요들이 있을 때 바이브 코딩을 통해서 필요 있는 그런 의미가 있는 가치가 있다라는 어떤 앱이 개발이 되면 그거는 회사의 기존에 가지고 있던 보안 체계를 철저하게 준수하는 그런 프로세스로 시스템을 개발한다. 그래서 그 모든 개별 직원들이 가지고 있는 아이디어는 충분히 구현을 하고 시험을 해보되 정말로 그게 입증이 되면 전사의 시스템으로 상향시키는 그런 방향으로 좀 진행을 하고 있습니다. 그리고 그러한 과정 속에서 최대한 그 데이터가 지켜질 수 있도록 별도로 샌드박스를 만들어서 이것저것 해볼 수 있게 클라우드 내에서 그런 환경들을 지금 구축 중에 있습니다.
I think your tip is very useful and practical. Thank you. Dr. 부영정?
I'm very confused because he just speaking in Korean, so now. But I definitely agree with his opinion because we also have same problems in our company. We also have a lot of vibe codings, and sometimes it cannot be some security. The problems. So, by the way, I think let me just let me start with the current AI trend first, because now the trend is the global AI trend is a little bit different. A few months ago, everyone says that the training AI model with the data was the single most important, but now the concept is a little bit different. Recently, the AI industry changed its focus from the training to inference. Now, the AI can thinking and reasoning. It is kind of inference ability. So it shows that big tech companies also investing a lot of money to inference rather than just training, because there are not much data remaining in AI just training. So that's why I just want to say why data is important in our industry right now. So. It means that the new models don't need heavy training because they are already smart. So as long as the AI can read the data, they can produce amazing results in our the request. So now we have some problem regarding our data strategy in 한미글로벌. We actually over the past 30 years we have conducted about 3,200 projects in 66 different countries, and we have 3 million project data and about 100,000 km data in our hand. But we cannot use this data properly in our system because this data is not AI ready, which means that it is not structured and it is not cleansed and it is not classified yet. So currently we just conducting the POC for data platform because because of the importance of data, we just plan to make some big data platform to utilize our AI system for the company. So anyway, our final goal is to build our AI-based working just programs like which called that the AI workspace, which is directly connect to our data platform. If our data platform is ready and our AI workspace is also ready, our competitiveness is much higher than before. So that's it for now.
Thank you very much. Although I agree a lot with your comments about not needing much data these days, there are still claims that we don't, as an industry, we don't have industry data like cost estimation data or project data as an industry. So the third question is, can we kind of utilize public data to fine-tune or whatever, train or make the AI more intelligent? Then if we want to do that, is there a way to connect them together and open them to the public without any legal issues? Or what should we prepare to do so? How can we connect them together as a connected data set? And I know that Professor André Borrmann and Professor Changbom Ryan did some work on this, AI-ready data and big data set preparation. So could you answer this question?
Yes, this is actually a big challenge, I would say, because especially in construction we have a lot of sensitive data. So it's clearly understandable that the companies do not easily share that information with the public. So, for example, also the video captures that we had from the construction sites, we were not allowed to make them public. I can show the videos, but not more. Like the raw data, I cannot share. So I understand, of course, the companies that they, for different reasons, want to keep their data. On the other hand side, as an industry, of course, we can only advance if there is at least some data. So we always try to convince our partners to be a little bit more flexible, to think twice which of the data is really sensitive and which of the data can be used for publications. And we as a university always want to publish the data that we use for our developments, for our software. So whenever it is possible, we really go this way and provide public data to the community, to the general public, because we know only then we can compare different approaches, only then we can really advance in the industry, but also in academia.
Okay. Dr. An?
Yeah, I also, for the broader audience, I will speak in Korean. I believe that it will be translated. 저는 이제 이런 인더스트리 와이드한 이런 그 데이터 축적을 위해서 가장 현실적인 방안 중에 하나는 사실 공공주도로 시작하는 거라고 생각을 합니다. 건설이나 토목에서는 사실 공공주도의 프로젝트들이 많기 때문에 그런 공공 부분이 이런 중립적인 플랫폼을 만들어낼 수 있다고 생각을 하고요. 사실 한국에서 이미 그 국토부 주도로 이런 노력이 이미 진행이 되고 있고, 제가 이번 주 월요일부터 수요일까지 또 ASC 컴퓨팅 컨스트럭션 이 컨퍼런스를 했는데 거기서도 얘기된 게 이제 ASC 미국 토목학회에서도 똑같은 논의를 하고 있습니다. 결론적으로 이미 이제 이런 공공 주도의 이런 데이터 인더스트리 와이드한 데이터를 축적하기 위한 인프라스트럭처는 만들어지고 있다. 그래서 이게 만드냐 마느냐 문제가 아니라 이것을 어떻게 하면 더 쓸모 있게 이 인프라스트럭처를 이제 저희가 활용할 건가인데 여기에 이제 제가 몇 가지 이제 단계가 필요하다고 생각을 합니다. 아까 사실은 그 닥터 볼만이 얘기했는데 그 데이터가 있다고 해서 그 데이터를 다 모으는 게 의미가 있지는 않거든요. 그래서 저희가 먼저 유스 케이스를 명확하게 하는 게 중요한 것 같습니다. 그래서 만약에 우리의 어떤 유스 케이스가 공정 지연을 이제 예측하는 거다. 그러면 뭐 기준 공정표, 실제 진행률, 날씨, 설계 변경, 현장 접근 문제, 뭐 지연 원인에 대한 데이터 이런 데이터들이 시리즈로 이렇게 엮어서 축적이 되는 형태로 이제 만들어져야 된다는 것이죠. 그래서 저희가 이런 데이터를 모으는 것을 저희가 데이터 레이크라고 이제 부르는데 이거는 이제 결국 어떠한 목적으로 데이터를 활용할 것인지를 먼저 생각해야 그것을 우리가 만들 수 있다는 것이고요. 그 두 번째로 또 중요한 것이 이제 인더스트리 와이드한 데이터를 모으려고 하면 사실 이게 여러 이 클라이언트들, 여러 회사들로부터 데이터가 오다 보니까 사실 데이터 간의 어떤 의미론적 불일치가 발생할 확률이 굉장히 높습니다. 그래서 여기서 중요한 것은 이제 이런 프로젝트 데이터들의 어떤 온톨로지컬한 구조를 만들어야 된다는 것인데 이 온톨로지 구조라는 게 뭐냐면 이 데이터 항목이 실제로 무엇을 의미하는지 그리고 어떤 개념들과 어떻게 이렇게 연결되는지를 뜻합니다. 예를 들면 이제 저희가 뭐 공정 지연이라고 할 때 이게 과연 이 최초 기준 공정표에 대한 지연인지 최신 승인된 공정표 대비 지연인지 아니면 시공사의 내부 공정표 대비 지연인지 뭐 이런 것들이 이제 서로 이 데이터 프로바이더마다 다를 수가 있거든요. 그래서 이것들을 이제 좀 일치시키기 위한 이 온톨로지 같은 것들이 잘 정립이 돼야 되고요. 그리고 또한 이제 이렇게 수집된 로 데이터들이 결국 AI가 활용할 수 있는 지금 저희가 많이 얘기하는 게 AI 레디 데이터라고 하는 건데 저희가 지금 현실에서 그냥 모으는 PDF 데이터나 뭐 스프레드시트나 BIM 모델 뭐 이메일, 공정표 이런 것들이 그대로 넣는다고 AI가 활용 가능하지가 않습니다. 그래서 이것을 활용하려면 사실은 AI가 읽을 수 있고 이해할 수 있는 형태로 데이터가 좀 정리돼야 되고 구조화돼야 되고 라벨링이 돼야 되는데 AI 시대에는 이제 이런 것들, 이런 프로세스 자체가 일단 또 만들어져야겠죠. 그리고 끝으로 이제 중요한 거는 이제 이 공공 데이터만 모여가지고는 이게 과연 의미 있는 데이터는 안 될 것이고 민간에서도 이 데이터 공유에 이제 같이 이제 협조를 해서 데이터를 가지고 공유를 해줘야 되는데 그러려면 민간 입장에서는 사실 자신의 데이터를 넣었을 때 이런 데이터가 충분히 어떤 민감한 데이터들이 이렇게 보호될 수 있는지 이런 보안 이슈가 명확하게 이제 좀 제시가 돼야 될 것이고 자기들이 이제 공유한 데이터에 대한 소유권, 사용권에 대한 규칙들도 많이 만들어져야 될 것 같습니다. 그리고 동시에 또 인센티브도 있어야 될 것 같고요. 사기업이 데이터를 이제 공공 인프라스트럭처, 이 데이터 인프라스트럭처에 공유를 했을 때 어떤 인센티브가 있을 수 있느냐. 다른 데이터에 대한 어떤 액세스도 있을 수 있고 혹은 공공 조달에서 어떤 혜택을 준다든지 이런 부분들이 또 필요할 것 같습니다. 그래서 제 생각에는 결론적으로 공공이 주도하는 이런 데이터 레이크가 출발점이 될 수 있지만 문제는 이제 이것을 결국 항상 중요하지만 잘하는 것이 중요한 것 같습니다. 네.
I think there was a very well established plan for collecting and mapping different sets of industry data. Let's move on to the next topic. They say that if we cannot manage, if we cannot measure, we cannot manage. So that's the next topic. And it, of course, takes a lot of money, requires a lot of money to adopt AI or do anything new. And from the industry perspective or company perspective, we need to be able to measure the impact of the adoption, new technology adoption. So we'd like to ask what might be the proper way of measuring the impact of AI implementation and adoption. So I'd like to ask this question to David Whysall and Dr. Bu Young and Dr. Kenyang Lee, from 3 people from the industry.
Okay. Perhaps I'll start. I agree. I say you get what you measure. So I think measuring things are very important. I think we look at it in 3 ways. One, and it's true in any business, AI usage that you've rolled out. So we're measuring, the amount of usage, the amount of tokens being used, the AI tools we've got across the business, and sometimes AI licenses can be rolled out, but it's not being used. So we can actually make decisions on where those investments go, and people can lose those investments if they're not using it. That's one thing. Firstly, secondly, we're looking very hard around use, obviously, again in service areas or service lines, we call it, and we're really testing whether we are doing our services more productively. So can we form schedules more quicker? Can we do cost estimates quicker? Can we do procurement reports quicker? And we're certainly testing that, and that's informing, again, where we make our investments at a service level. But ultimately, it's about measuring the value on projects. So ultimately, we're trying to measure, is it making the projects quicker? Is it improving health and safety statistics? Is it delivering real value? That's where we've got to, I think, as an industry, get to, measuring the value of AI at a project level, ultimately. And as I said earlier, AI will change. It's providing great opportunities today, but where it will be in a year's time, 2 years' time, 3 years' time, will be far beyond where it is today. So I think it's important that we continue to reflect and think about that, as we plan our AI investments.
이번에도 2가지를 좀 말씀 좀 드리겠습니다. 첫 번째는 가장 간단하게 해볼 수 있는 게 그냥 업무 시간 단축부터 시작하는 겁니다. 그래서 기존에 했던 게 뭐 이틀 걸렸던 거를 뭐 30분만 끝냈다. 그러면 이제 그거 곱하기 뭐 시간당 이렇게 해서 하는 거고요. 그런 것들을 주로 하는 데가 본사에서 많이 합니다. 근데 본사에서 해봐야 별 소용이 없고요. 현장이 300개면 현장에서 할 수 있는 걸 하셔야 가장 쉽습니다. 곱하기 300 하면 확실히 효과가 있기 때문입니다. 그런데 그거보다 더 나가야 된다고 생각하는데 보통 그렇게 하면 그러면 뭐 1년에 뭐 몇만 시간 줄었네? 그러면 우리가 프로젝트를 그만큼 더 많이 해? 또는 그래서 사람이 줄었어? 이런 질문에 대답을 할 수가 있어야 되거든요. 그러려면 이제 어쩔 수 없이 HR 쪽 이슈가 같이 나오게 됩니다. 그래서 그런 조직과 같이 상의를 해야 되는 상황이 되는 것 같고요. 또 그러다 보면 왜 CEO와 최고 경영자가 AI를 알아야 되는지의 문제까지 올라갑니다. 그러면 이 정도면 아무도 밑에서는 3명 줄여도 됩니다라고 얘기를 못하기 때문에 위에서 이해를 하고 이 정도는 내가 전문가적인 직관으로 몇 명을 줄일 수 있겠구나, 또는 프로젝트를 몇 개를 더 줘도 되겠구나 라는 판단을 위에서 어쩔 수 없이 책임을 가진 사람이 내려줘야 되는 그런 게 하나가 있고요. 두 번째는 그 기반이 되는 것들을 좀 갖춰야 될 필요들이 있습니다. 우리나라 현장의 대부분의 데이터들은 어떤 식으로 되어 있냐면 아래 한글 또는 엑셀에 되어 있습니다. 그런데 그게 들어가 있는 게 표준화되어 있는 게 아니라 발주처, 그리고 감리회사 또는 관공서, 관련된 관공서에서 원하는 포맷으로 되어 있습니다. 그런데 이게 뭐 프로젝트가 100개면 100개가 다 다를 거잖아요. 그래서 데이터를 취합해서 분석을 하고 비교를 해서 요번에 내가 AI를 프로젝트를 적용을 했더니 안 했던 것보다 뭐 얼마큼 좋아졌다, 비교 대조군을 만들 수가 없습니다. 그래서 그런 것들을 통일을 시키는 것부터 먼저 해야 되고요. 그러려면 다 할 수가 없기 때문에 원소스 멀티유즈의 방향으로 사내에서 데이터, 일단 사내 시스템을 공통적인 데이터들을 한 군데 모아놓고 이것들을 뭐 AI 에이전트를 만들든 아니면 자동화 툴을 이용하든 각 회사, 각 그 이해관계자들이 요구하는 양식으로 자동으로 변환해 줄 수 있는 그런 방식의 시스템들이 좀 필요합니다. 다 할 수가 없습니다. 그래서 또 그 중에서도 가장 공통적인 거, 뭐 여기 20대 80의 법칙을 넣는다든지 뭐 해서 중요한 것들부터 먼저 하고 나머지들에 대해서는 우리 이해관계자들이 또는 책임 있는 분들이 고객과 이해관계자에게 이런 형식으로 가야 됩니다. 이런 양식으로 좀 개선되어야 됩니다. 이런 통일된 양식을 사용할 수 있게 해주세요라고 그 합의를 도출해내는 것까지 참여해야 정확하게 AI 프로젝트가 도입이 됐을 때와 안 됐을 때의 메저링이 될 수 있고 비교가 될 수 있을 거라고 생각합니다.
Thank you. Dr. 부영정.
Okay, regarding measuring the impact of AI adoption, showing the the returns in financial value is not easy and not realistic. So in our company, we just evaluate the measuring the impact of adoption is just we look at how much our users just feel their work has improved. So we conducted a survey a few months ago regarding AI use in our company. The result is amazing. About 75% of our employees feel their productivity just goes up by 20%, and 30% of our employees feel a big jump of 50% in productivity increase. So because of AI is spreading so fast into our daily processes, so I think the impact of AI adoption is much better than we expected. And our company Hanmiglobal now evaluate the performance of AI adoption in each team as a core KPI of a team evaluation. We evaluate each team a few days ago. Our evaluation focused on how much they changed their old way of work process by using AI, rather than just looking at their cost savings and time savings. We just focus on how they re-engineer their process by using AI. That is main focus on our evaluation in AI use. Now we also according to the survey, we also have the survey about our pain points on site. In the pre-construction stage, the first one is design review. The second one is rough cost estimate, and third one is value engineering reviews. And during the construction stage, the pain point is that design changes and change order is the main top priority of pain points. So now we are developing some type of PM modules directly related to these pain points, which will make our productivity much higher. So if AI takes away kind of paperwork, and if AI can make technical review much faster, our PMs our project manager can focus more on their original job, like managing high risk tasks. That is the main ROI of AI investments right there. So thank you.
Okay, I'd like to ask follow-up questions, but I'll save it so that we can keep on the our schedule. So let's move on to the last question, which is difficult because we know that AI has a risk, but we don't know how to deal with it. We fell in love with the convenience of AI since we are very lazy. But anyway, I'd like to ask Dr. Rafael Sacks and Changbom Ryan An and Kunyang Lee about how to deal with the risks that we have due to the AI use of AI and legal accountability issues. Would you like to start?
I would like to use the question to turn it around a little, which is to say that we are in an industry which has a very high rate of litigation and disputes. And that litigation and disputes arises because we have siloed companies, each of whom have responsibility for a very particular piece of the work. And we're not always able to deal, on the one hand, with clear definition of what the work is so that there are no disputes, but we deal with a great deal of uncertainty in our processes, and we deal with often very fast processes, so we don't have the time to build the clarity. And so I would hope that in the first instance, using AI to be able to respond to design review, to review contracts, to review bills of quantities, to check whether they conform with what's in the drawings and the designs and the BIM models and so on, across the range of all the information we're using, may lead us to have much better quality information and much fewer places for dispute, which should lead to improvements in accountability in the sense that we may be better positioned to take responsibility and assume accountability and liability for what we're doing than we were in the past. And that fundamentally, in the end, the question is one of insurance. Because right now, it's not whether we'll make mistakes. We're all going to make mistakes. It's a question of how we deal with them, how our business models and business relationships are set up to deal with them, and then, in the end, where we litigate or where we don't, and where we pay. Like in the car industry, we see that insurance premiums for autonomous cars are much lower than they are for human-driven cars. I expect that the record of performance over time will be such that the problem may not be one of accountability, but it may be one of statistically saying we're a much more reliable industry. We still have issues of accountability, but we'll deal with those by having insurance for more narrow things, and where it may be true that in some places some AI tool made some decision that led to some negligence or even an accident, but in the global picture of things we'll become more accountable, less negligent, lower insurance claims, even though we may not be able to solve the question of who was responsible.
저는 이 문제가 사실은 처음에 이 질문을 주셨을 때 어려운 문제라고 생각을 했었는데 생각을 해보니까 이게 생각보다 굉장히 straightforward한 문제더라고요. 기본 원칙 자체는 뭐냐면 AI가 어떤 책임의 공백을 만들어서는 안 된다라고 저는 생각을 합니다. 그래서 결국 무슨 얘기인가 하니 어떤 조직도 이거는 우리 결정이 아니라 AI가 내린 결정이다라는 식으로 책임을 회피할 수 없는 구조가 되어야 된다. 그러면 AI가 사용되더라도 책임은 여전히 명확하게 어떤 지정된 사람과 조직한테 있어야 된다는 거죠. 그래서 예를 들어서 AI 프로그램을 공급하는 업체는 그 시스템이 제대로 작동하는지, 그리고 문서화나 보안이 충분한지, 그리고 시스템의 한계, 뭐 할 수 있는 거 없는 거 이런 것들에 대해서는 책임을 질 수 있습니다. 하지만 이제 그 데이터가 AI한테 제공된 데이터가 정확한지는 실은 시공사가 이제 책임을 져야 되는 것이고요. 그리고 발주자는 이 AI를 여기에 사용해도 된다는 것을 승인하는 데 대한 책임을 지는 것이고, AI가 내온 그 어떤 그 결과 자체에 대해서 이것을 프로젝트의 어떤 중요한 의사결정에 쓸지 안 쓸지는 PM이나 프로그램 매니저가 이제 결정을 하게 되는 어떤 구조라고 생각하면 조금 굉장히 단순하다고 저는 생각을 합니다. 근데 이제 이게 실제로 작동하게 하기 위해서는 뭐 몇 가지 저희가 조금 생각할 게 있는데, 먼저 이제 AI 활용 자체를 위험 수준에 따라서 좀 분류를 해놓는 게 필요합니다. 예를 들어서 그냥 회의록을 요약한다 이런 것들은 사실은 큰 리스크가 안 들기 때문에 굳이 이게 크나큰 어떤 이것을 AI의 어떤 결과물을 다시 체크하는 과정은 필요 없을 텐데요. 근데 만약에 AI를 뭐 구조 설계를 승인한다든지 현장 작업을 중단한다든지 뭐 기성 지급을 승인한다든지 이런 데 사용하는 것은 분명히 고위험군이기 때문에 이런 경우에는 이 엄격한 검증과 사람의 감독이 필요하다. 그래서 이것은 리스크 레벨에 따라서 얼마만큼 사람이 검증해야 되는지를 미리 저희가 결정을 해놓으면 된다는 것이고요. 그리고 두 번째로는 이제 프로젝트에 AI 책임에 대한 매트릭스를 만들어 두면 좀 될 것 같습니다. 그래서 누가 이 AI 시스템을 소유하고 있는지, 지금 사실은 PM도 있고 GC도 있고 전문 건설 업체들도 있을 텐데, 그때 이 AI 시스템을 소유한 사람은 누구고, 데이터를 소유하는 사람은 누구고, 이 결과가 나오면 검토한 사람은 누군지, 그리고 최종 결정을 내는 사람은 누군지, 시스템 자체에 대해서 검증하는 사람은 누군지, 이렇게 개별로 명확히 정의를 해놓으면 단순히 이제 이것을 그냥 프로젝트 팀이 책임진다라고 해놓는 것을 넘어서서 이 명확한 어떤 책임 소재를 둠으로써 인해서 의사결정이 명확해지고 나중에 책임 소재도 명확해질 수 있다고 생각합니다. 또 그러기 위해서는 실은 이게 계약 단계에서부터 이런 내용들이 다 포함이 돼야 될 것 같아요. 계약 단계에서부터 AI 활용에 대한 프로토콜 자체가 정의가 되어 있어야 될 것 같습니다. 그래서 어떤 AI 시스템을 이 프로젝트에서 사용할 수 있는지, 어떤 목적으로 사용할 수 있는지, 그리고 어떤 것은 금지돼야 되는지, 어떤 사람이 이것을 검토해야 되고, 데이터 소유를 누가 하고, 결과가 잘못되면 누가 책임지는지 저 정도가 이런 그 계약 단계에서부터 명확히 이제 정의가 된다면, 그것 또한 이제 이런 이 어카운터빌리티에 대한 이슈를 잘 회피할 수 있을 것 같습니다. 그래서 예시를 제가 하나 만들어 봤는데요. 예를 들면 이제 AI 공정 관리 시스템이 뭐 기계 설비한 하도급 업체가 20일 늦게 작업을 끝낼 수 있다고 예측을 했다라고 이제 저희 가정을 해보면 이 예측만 믿고 바로 뭐 돌간 작업을 지시하거나 혹은 지체 상금을 물리거나 하는 결정으로 바로 이어져서는 안 될 것 같고요. 그럼 이 예측을 기반으로 이제 리스크 검토를 이제 시작을 해야 되고, 그러면 아마 뭐 프로젝트 관리자는 이제 기존 공정표나 다른 것들을 보고 확인하고 프로젝트 관리자가 결국 이 예측을 받아들일지 안 받아들일지를 이제 결정을 하게 되는 거죠. 그럼 그 결정에 대한 책임은 결국 프로젝트 관리자가 이제 지게 되는 형태로 되게 될 것 같습니다. 그래서 결론적으로는 저는 이제 분쟁을 나중에 끝에 가서 어떤 분쟁이 생길 수 있는데, 분쟁을 예방하기 위해서는 이런 AI의 모든 어떤 기술적 세부 사항들이 완벽하게 설명 가능해야 된다라고 생각하진 않아요. 그러니까 지금 한쪽에서 얘기하는 건 뭐냐면 이런 AI 어카운터빌리티 이슈를 피하기 위해서는 AI의 어떤 과정 자체가 explainable 해야 된다. 그래서 explainable AI가 도입돼야 된다고 얘기하지만, 사실은 저는 explainable AI가 도입된다고 해서 이 어카운터빌리티 이슈가 사라질 거라고 생각하지 않고, 저희가 사실 그동안 저희 건설업에서 해왔던 형태, 여러 가지 시스템을 도입할 때 저희가 그 예를 들면 저희가 BIM 시스템을 도입할 때 이 BIM을 누가 만들고 소유권은 누구고 이런 것들 다 정의했던 것처럼, 이 AI 시스템을 도입하는 데 있어서도 그런 것들 다 정의함으로 인해서 이 어카운터빌리티 이슈가 좀 더 명확해질 수 있을 것 같습니다.
Thank you very much for the detailed and insightful comments.
마음이 급하네요. 시간이 얼마 안 남아서. 그 기업 입장에서 간단하게 좀 말씀을 좀 드리겠습니다. 제 고민은 기존까지의 AI, 지금까지의 이런 혁신적인 모두의 관심을 끌었던 AI는 질문을 하면, 프롬프팅을 하면 대답을 주는 이런 형태였습니다. 이제는 본인이 알아서 판단하고 본인이 알아서 실행까지 하는 AI 에이전트들이 요즘에 막 나오고 있습니다. 그 전에는 물어보면 대답을 가지고 우리가 판단을 하면 됐었거든요. 최종 책임을 사람이 했으면 됐는데, 이제 에이전트를 사용하면 에이전트가 본인이 판단해서 본인이 그냥 실행을 합니다. 물론 뭐 물리적으로 하지는 못하고 이제 피지컬 AI가 돼야지만 물리적으로 하겠지만 대부분의 경우는 본인이 합니다. 사이버상에서는. 이게 가장 큰 문제 이제 도래될 것 같고요. 그거에 대한 고민이 가장 큽니다. 저희 고민하고 있는 방향은 계속 얘기하고 있는 게, 업계에서 하고 있는 단어로는 가드레일이라는 것들을 만드는 겁니다. 가드레일을 두 군데서 만드는데요. 입력할 때 가드레일하고 나올 때 가드레일입니다. 만드는 개발자들이 지켜야 될 가이드레일, 그리고 그 질문들, 요청을 할 때에, 분석할 때의 요구들, 프롬프팅에서의 가이드레일을 정확하게 만들어주는 것들이 필요할 것 같고요. 저희가 이제 뭐 만들었다기보다 준비를 같이 하고 있습니다. 또 나중에 이제 아웃풋에 대한 가이드레일들이 중요할 것 같습니다. 아웃풋이 그 오류가 났을 때 이걸 어떻게 검증할 것인지, 그리고 우리 조직에 맞게 우리 조직의 디시전과 다른 것들이 있는지를 검증을 어떻게 할 것인지, 그리고 그러한 의사결정 과정들을 AI가 내리는 과정들을 어떻게 로그를 남겨놓을 것인지 이런 것들을 가이드레일을 만들어야 되는 것들이 필요할 것 같고요. 가장 기본적인 전제는 이런 어카운터빌리티를 이야기할 때 그럼에도 불구하고 사람보다는 낫다라는 그런 좀 불편한 진실들이 좀 있긴 있습니다. 그래서 그런 것들이 발생할 수밖에 없지만 나중에 이것들을 우리가 어떻게 빠르게 복구를 시키고 다시 의사결정을 다시 할 수 있는 체계를 만들 것이냐가 더 기반에 깔려 있는 그런 전제라고 할 수 있겠습니다.
Thank you very much. We talked about 5 topics which are not easy to answer, and I'd like to thank all 6 panelists for doing their best to answer these tough questions. Thank you very much. Let's give them a round of applause. And I also like to thank everybody for being here until the last session. Thank you very much.